सभी को बहुत बहुत नमस्कार. मेरा नाम खुशवंत फतनानी है. My name is Khushwant Fatnani. I'm an educator, mentor and coach. Here, I have with me students of class 11th. Together, we are preparing for physics for JEE and NEET. So, let's begin with the session for the day. Welcoming everybody here on the Zoom platform, Achal, Aryan, Ridhima, Ronit, Vasu. All of you who are watching us via YouTube platform, feel free to contact me on my number, which is 79743553, if you would like to be a part of these classes where we discuss, learn and evolve as we are working on these questions and making ourselves better every class. तो शुरुआत करते हैं एवरीवन. वी हैव स्टार्टेड विद द चैप्टर रोटेशनल मैकेनिक्स, रोटेशनल डायनामिक्स, सिस्टम ऑफ पार्टिकल्स एंड रोटेशनल मोशन और सिंपली रोटेशन. जो भी नाम कह दो, देयर आर डिफरेंट नेम्स, कॉन्सेप्ट, सिनेरियो, एवरीथिंग सेम. Sharing the screen with all of you. आंचल कंफर्म करना if you all will are able to see the screen. I'll just share it, है ना. So rotation, yes, okay, I will just share the screen with all of you. हाँ, देखो तो आंचल, स्क्रीन दिख रही है क्या आप लोगों को क्लियरली?
Yes, sir, it's visible.
Okay. So now let's have a look, everybody. Let us see one by one every topic as we had discussed. In the last class, we had seen the concept of a rigid body. What is a rigid body, Anshul? क्या होती है rigid body? Yes.
The
Anshul.
body which has a constant volume and shape.
हाँ, and its intermolecular distance does not change with time. Such bodies are called as rigid bodies.
Bodies.
Chalo, good. Today, let us understand what is moment of inertia and what is torque. So this is a very beautiful concept and will be very helpful as we are traversing this chapter. अभी in case of linear motion, अच्छा, these were also certain equations that we had seen, है ना, last class में we had seen revisited these equations. We have also seen them while doing circular motion. And let's take a question, one or two. Let's solve some questions based on these equations. शुरू करते हैं, everybody. Right, so here is your first question coming up for the day. I'm very sure you all are doing assignments and making sure that everything is tip top and updated. Weekends wo time hota hai, right? Weekend is that time where you can update your notes, whatever formula notes you're making. Start making formula notes for HC Verma, for rotation motion, and at the same time please start reading from HC Verma. I am again and again saying जो भी अभी चल रहा है, whatever is going on right now, please catch up with that, complete your assignments, be regular, ठीक है? Because later complaining कि सर मुझे तो समझ नहीं आ रहा, सर मुझसे तो सम नहीं बन रहे, या कल मेरा पेपर है मैं क्या करूं सर, अभी ये क्या करूं सर, 12 o'clock पे मेरा डाउट बता दो, तो ये सारी चीजें होंगी नहीं. All of this will not happen at all if you all are working in the day itself. इज दिस क्लियर? वासु, रिधिमा, ये सब होगा ही नहीं सर, मुझसे तो बन नहीं रहा सर, मैं क्या करूं, ये सिचुएशन को कोई सामना ही नहीं करना पड़ेगा अगर रोज का रोज काम किया, राइट? तो एवरीबडी, नॉट जस्ट टू पीपल. आई एम सीइंग बहुत सारे बच्चे हैं जो कई बार असाइनमेंट्स टरका देते हैं बात के लिए, सर कल, सर परसों, अगले हफ्ते सर. हाँ, वो हैबिट से बाहर आना है, तभी आगे चल के पेपर क्वेश्चंस बनेंगे. तुम लोग कैसे एक्सपेक्ट कर सकते हो कि मुझसे सवाल बन जाए अगर मैं मेहनत ही ना करूं तो? मतलब ये तो ऐसा हो गया कि मैं पेड़ के नीचे बैठ जाऊं, ऊपर से फल गिर जाए. तो रिद्धिमा, ऐसे संभव है क्या? हाँ, तुम बस बोलो कि ऊपर से गिरते जाए फल, मैं खाते जाऊं, ऐसे पॉसिबल है क्या, बताओ?
नहीं सर.
हाँ, तो फिर मेहनत तो करनी पड़ेगी ना. कब शुरू कर रही हो तुम मेहनत? तुमने बोला था सर मैं कल से कर रही हूँ. हमने शुरू किया,
सर मैं आज से करी शुरू.
रिवीजन करना है, ठीक है? इतना ही अभी मैं मिनिमम तुमसे एक्सपेक्ट कर रहा हूँ. मिनिमम इतना करो कि सिर्फ रिवीजन करना है, ठीक है? मैं एक्सपेक्ट नहीं कर रहा कि तुम अपनी क्लास की टॉपर बन जाओगी यहाँ पर आकर, लेकिन हाँ, रिवीजन तो कर सकते हैं अपन, थोड़ा सा ही सही, बट रिवीजन शुरू करो, ठीक है? धीरे धीरे हार्डवर्क से ही आदमी आगे बढ़ता है, तो वो अपन को सीखना है. चलो, ठीक है, गुड. आई एम हैप्पी कि तुमने शुरू किया रिधिमा, गुड. चलो एक बार रिधिमा के लिए जोरदार तालियां हो जाए क्या एवरीवन? यस, कैन वी हैव बिग राउंड ऑफ अप्लॉज? बच्ची ने कोशिश तो शुरू की. हाँ, आई एम हैप्पी कि तुमने कोशिश की. गुड 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 गुड, वेरी गुड, गुड. चलो, कोशिश करने वालों से तो आगे गाड़ी बढ़ती है ना, वरना कैसे गाड़ी बढ़ेगी? सो यू ऑल आर गिवन, एवरीबॉडी हैव अ लुक. देयर इज अ रोटेटिंग रॉड, ठीक है? वी हैव अ रॉड हियर, ठीक है, विच इज रोटेटिंग. वी हैव अ रॉड हियर विच इज रोटेटिंग. अभी दिस रॉड के लिए एंगुलर एक्सेलरेशन इज गिवन. रॉड के लिए एंगुलर एक्सेलरेशन इज गिवन एज 3 radians per second square. You are being asked that what is the angle covered in time t is equal to 20 seconds. In 20 seconds, what is the angle covered? Very simple question. Try this out. Let me know if you're able to crack this one. Everybody get ready, putting the options here. So all our YouTube viewers, I'll launch a poll for all of you too. Everybody who's attending this session live will have the advantage of going through the polls. So यहाँ पे poll शुरू करते हैं. Before that, everybody start making your calculations. आंचल कौन सी equation use करेंगे out of the 3 equations that you all know? Hint ले लेते हैं. Yes, बोलो. आंचल, which equation should we use?
The first one.
थीटा निकालना है. बोलो. Half
Sorry, theta.
alpha t
Half
square.
alpha t
Yes.
square plus
Omega naught
omega
t.
t.
Chalo, everybody go ahead, make your calculations. Well, shortly put the options here on the screen. Yes, dear learners, go ahead. Come on. Question is simple, still काफी time दे दिया. Let's have a discussion, everybody. Your options are here on the screen. 60 radians, 6 radians, 600 radians, or none of these. I repeat, you are being told there is a rod which is rotating about an axis, central axis से. Its moment of its angular acceleration is given 3 radians per second square. Angle rotated needs to be calculated. Time is given as 20 seconds. Let's start the poll, everyone. Here is your poll. Going ahead with it. Yes, sure. Everybody, go ahead. You all can do it. Take not more than 30 seconds. Yes, because already I've given a lot of time. Yes, everybody. Initially, no velocity is given, so you all can take initial velocity as 0. ठीक है? Right. 15 more seconds. Easy question. बहुत simple question. Yes, dear learners, go ahead. All right. 5, 4, 3, 2, 1. Done. Sure. Let's close the poll now. Good. All right. Let's share the results. So 67% of those answering have been able to answer it correctly. Let's have a quick discussion with all of you, dear learners. So. Okay, those who could answer option number C, can I have a quick raise of hands? जल्दी से. Yes, dear learners. कितने लोगों का आंसर ऑप्शन नंबर C आ गया? So रिद्धिमा, very good. आंचल, and one more, right? 3 of you could get it. आर्यन, चलो. आर्यन, मुझे बताना नंबर ऑफ रोटेशंस को हम कैसे डिनोट कर सकते हैं? अल्फा इज इक्वल टू ओमेगा नॉट टी प्लस हाफ अल्फा टी स्क्वायर. करेक्ट. अच्छा, शुरुआत में नथिंग इज गिवन, तो ओमेगा नॉट को कैसा ले लें? 0. अब वील हैव हाफ. अल्फा कितना दिया है आर्यन? 3. So 3 what is t given? 20. तो 3 into 20 square कितना हो गया? देखो आर्यन, half into 3 times of 400, which comes 3 into 200, which is equal to how much? बोलो आर्यन. 600 radians. Easy. Yes. क्या शुरुआत में no velocity is given. Initial velocity is 0. Rutik is saying hi. Hi Rutik, welcome to the session. Right, so I hope this logic is clear to everybody. क्या simple substitution and calculated the radians में angle. Now how many of you are clear? कितनों लोगों को अब clear हो गया? Yes, Ridhima is clear, so is Anshul. Please raise your hands. Ronit, Vasu, Aryan, if this is clear, a quick raise of hands. Okay, लिख लो, write this down in your copy and write a W. When you all are done writing, write a W. Yes, dear learners, quickly write a W on the screen once you all are done writing, or simply bring your hands down. Yes, hands down कर लेना when you all are done writing. Yes. Over to you, dear learners. Yes, let me know once you all are done. So started off with the session for students of class 11th. Everybody, I've sent the link on the Telegram channel also. We'll paste it here once you all are done. Great, superb. So let's take the next one. अगला सवाल लेते हैं everyone. अभी ना you are given same question. Same question is given. ठीक है, like this. Let's write it here. Same question. You're again being told that in this question, आपके पास फिर से there is a rod that is rotating. Let's make the rod. This is rotating about a central axis. It's given alpha value is equal to 10 radians per second square. They are giving you time value as 2 seconds. They are now asking you how many rotations will it make? How many rotations will it make in 2 seconds? How many rotations will it make in 2 seconds? अब की बार number of rotations they are asking. Number of rotations made in 2 seconds. है ना? चलो. I hope you all are ready. Simple question. चलो, try this out everybody. First calculate the angle. फिर देखो that much angle will be covered in how many rotations? Because one rotation means 2 pi radians. Calculate it and then go for it. Everybody. हाँ. करो calculate. Even if you're not able to do it's okay. I'll write down the options here on the screen very very shortly. Option A, B, C and D. They're coming here. Tab tak everybody go ahead with your answers. Yes. Your options are here on the screen, everyone. Have a look. So your options are, let's write them. Your options are 5 by pi or 20 by pi, 10 by pi rotations or none of these. You have to calculate number of rotations made in 2 seconds. Starting with the poll, dear learners. Yes. शुरुआत हो रहे हैं poll की. Over to you, dear everybody. Come on. Yes. We'll also start the poll on YouTube for those of our YouTube viewers very shortly. Yes, poll is there on the screen. Try this out. See, funda is calculate the number of calculate the angle covered. ठीक है? So 2 pi radians means one rotation. 2 pi radians means one rotation. So how many rotations will come in the number of angle that you are getting? चलो, everybody. Yes. कोशिश करो. 2 pi radians would mean one rotation. तो जितना भी एंगल आ रहा है उतना एंगल कितने रोटेशन में कवर होगा? ओवर टू यू एवरीवन. यस, क्विकली. ओके, लेट्स टेक 5 more seconds. 5, 4, 3, 2 and 1. क्लोज करें एवरीबॉडी. ओके, क्लोजिंग द पोल, शेयरिंग द रिजल्ट्स. So 67% of those answering have answered it correctly. Very good, very good, शानदार है ना. So let's have a look at the poll का results. I think I've already shared them. हाँ. So अभी how many of you could give the answer option number B? जल्दी से let me know. Yes, how many of you could give answer number B? Raise your hands. So Ridhima, Makesh, Aryan and anybody else who could give answer number B? I think 4 of you have given, right? जल्दी से. Okay. So let's make this with Ronit. Ronit, formula क्या था? What was theta equal to? हाँ, Ronit पूछो. What was theta equal to? Theta was half omega naught t plus half alpha t square. फिर से बोलो रोनित. Yes, what is the formula for angle rotated? हाँ.
Omega into t plus half
Alpha
t square.
चलो, good. अभी we know the formula. ठीक है, for angle rotated. शुरुआत में is any omega naught given? Omega naught दिया है क्या क्वेश्चन में? नहीं. तो कैसा ले लेंगे? 0. There is no velocity शुरुआत में. शुरुआत में this or this rod was at rest. अभी half alpha t square. Alpha कितना दिया? देखो तो रोनित. 10.
10.
T is given as 2. कर दे. यहाँ पर substitute क्या हो जाएगा? 10 into 2 which is equal to 20 radians, है ना? तो 20 radians is the angle rotated. Now we want to calculate how many rotations have been made by the rod. अभी मुझे बताओगे एक rod को एक बार rotate करोगे तो कितना angle cover होता है? रोनित, what is the angle covered when you turn the rod one time?
2 pi radian.
360 degree है ना, which is 2 pi radians. Very good. So 2 pi radians implies one rotation, which means that 20 रेडियंस में कितनी रोटेशंस होगी, कैसे करोगे, क्रॉस मल्टीप्लाई 20 into 1 20 into 1 divided by 2 pi, करेक्ट रोनित?
Yes, sir.
क्या हो जाएगा बोलो, इक्वल टू 10 by
10
pi, है ना, 10 by pi. तो आंसर कैसा आ गया, ऑप्शन नंबर सी.
C.
So those who have answered option number B are correct answers. Option number C is the correct answer. Good. How many of you could answer option number C? Now raise your hands, dear learners. jaldi se. So Aanchal could and Ronit could. अरे वाह. Okay, तो आज बाजी पलट गई. Okay, चलो good. इस बार मेजोरिटी ने गड़बड़ कर दी थी. आर्यन देखो क्लियर हुआ क्या? Is this now clear to you? Yes,
sir.
Okay, Makesh, is it now clear to you?
Yes, sir.
Okay. Ridhima, is it now clear? देखो Ridhima.
Yes, sir.
Vasu, how about you? Is it clear? Doubt हो तो please ask Vasu. Yes. हाँ.
Clear.
Clear है. Okay, everybody bring your hands in the raised position once you all are done writing. Quickly write this down into your copies. Once you all are done writing, kindly raise your hands. Over to you, dear learners. Come on, come on, come on. Next question is popping up on the screen. Jaldi se. Once you all are done, raise your hands. Let's move to the next question. Okay, jaldi se everybody. Come on, come on, come on. Waiting for you. All done? Raise your hands. Okay, Aanchal is done. Very good. Ronit has completed. Ridhima. Okay. Then we have Makesh. Aryan has also completed. Vasu, come on. Okay, great. Superb. Now let's take the next question coming up here on the screen. Okay. So here is the screen पर आ रहा है question on the screen. Okay. तो now सवाल देखना है everybody. Very interesting simple question. This time they are telling you कि theta value is given. This time they are telling you theta value is given like this, huh? So they are giving you theta value as 6t cube, है ना, 6t cube, simple 6t cube only. They ask you calculate the value of angular velocity omega, or angular velocity is asked in the question. Everybody, I repeat, they are giving you theta value. How is it varying with time? अभी वो पूछ के आ रहे हैं angular velocity या omega is being asked in the question. चलो पटापट से here are your options coming up. Simple सवाल दिया है. When, at what time? At t is equal to 1 seconds. At t is equal to 1 seconds, है ना? So here are your options on the screen. Everybody, come on, get ready. Your options are 9 radians per second, or 18 radians per second, or 27 radians per second, और none of these. कोशिश करो ज़्यादा ज़्यादा ये होगा कि नहीं आएगा. No worries. We'll launch the poll quickly on the YouTube channel also. So for all our viewers and learners here on Zoom, poll आ चुका है. Poll has started. Take not more than 30 seconds to crack this one. Grace may take 30 more seconds, no worries, but कोशिश कब को करनी है? Everybody has to try. Come on, जल्दी से everybody. Let us see how many of you are able to catch up with this one. हाँ, so YouTube पर भी poll has started and here on the Zoom the poll has also started. चलो 22 seconds over. हाँ, अभी 7 more. Okay. 4 more to go, 3 more to go. Okay. Now come on, जल्दी से. अरे 30 seconds और second grace दिया. चलो जल्दी से. 30 more seconds as 30 more seconds as grace time to all of you. Good, very good. Many of you, 100% till now is the poll का result. Very good. I'm so proud of you all, dear learners. Good. क्या बात है. How are you all managing to learn so well? क्या हो रहा है ये अचानक से भैया, ये सारी बाजी पलट कैसे रही है? मेरे बच्चे इतने होशियार कैसे होते जा रहे हैं? How are my learners becoming so better every class? Okay, 2 more seconds to go. Come on, your time ends now. I'm switching off the poll का options here. Okay, great. On YouTube also let us end the poll, है ना? Very good. चलो, the poll has ended everywhere. Let us share the results to all of you. With all of you. So here we see 80% of those answering have answered it correctly. How come such a great output hai? Chalo, very good. I'm happy and proud of you all. Let us see if really option number B is the correct answer. We don't know. Majority of you say it is B, but let us check. Okay, who would like to try this and answer? How many of you would like to try it? Aryan, try karna. Let's try this along with me, Aryan. हाँ. So क्या होता है? What is angular velocity? By the way, formula पता है क्या?
D theta by dt.
हाँ, ओमेगा इज डी थीटा बाय डी टी. अभी थीटा का वैल्यू, व्हाट इज थीटा का वैल्यू आ रहा है?
6t cube.
हाँ, t 6t क्यूब. डिफरेंशिएट करने के लिए व्हाट इज द जनरल फॉर्मूला आर्यन? d by dt of t power n is equal to how much?
Sir, nt n minus 1.
nt n minus 1. मतलब जो भी ऊपर रहता है that comes in front, right? इसका मतलब अगर यहाँ 3 ऊपर है so 3 will come in front. Am I correct, आर्यन?
Yes, sir.
Whatever is on the top or the power that will come in front. So 3. And in what remains in the power is n minus 1. What remains in the power is n minus 1. तो आर्यन यहाँ power में 3 minus 1 will remain. Correct, आर्यन?
Yes, sir.
तो अभी फाइनल क्या आ जाता है आर्यन?
18t square.
18t square. Are we asked omega as a function of time या हमसे पूछा गया है omega at t is equal to 1? आर्यन, what is asked?
Let t equal to 1.
हाँ, तो यहाँ पे let us substitute t is equal to 1. तो क्या आ जाएगा आर्यन? What will be the answer
Sir,
there?
18 radian per second.
हाँ, so answer will come as 18 radians per second. Why per second? ऐसा क्यों? Per second क्यों? Because
Sir,
it is
angular velocity is calculated.
angular velocity. Good. Angle covered per unit time is what is being calculated. Very good. Super Aryan. How many of you could register this in your minds? Kindly bring your hands down. Ridhima can also bring her hand down. I think now she has raised it. Okay, chalo. Everybody kindly bring your hands down. अगर mind में register हो गया. If there is any doubt, feel free to open your mask, open your mic and ask. हाँ. Dear learners, फटाफट चलो जल्दी से everybody done फटाफट quickly let me know, is this clear, easy, चलो simple, okay, very good, superb. One more question coming up to all of you, ठीक है? Write this down, raise your hands. जैसे ही लिखना हो जाता है everybody will raise their hands. Dear learners, come on, yes. Everybody watching us via YouTube can write written sir, done sir, so that we can move ahead. Everybody, come on. Yes, once you all are done, sir, written or write this as hand raise कर लो फटाफट on the screen. मैं सबका wait कर रहा हूँ. Okay. So Ridhima has completed, so has Makesh, Ronit, Aryan, and now I think we have Achal and Vasu are still writing. Okay, once you all are done, Achal and Vasu, please raise your hands waiting for you. Alright, Achal has also completed. Vasu, please take a screenshot. Moving to the next question. 5, 4, 3, 2, 1. Okay, great, super. अभी ना देखोगे everybody, we all have learned a lot. बहुत कुछ सीख लिया. Now give the heading moment of inertia. Moment of inertia. तो दिस टॉपिक इज अ वेरी सिंपल टॉपिक. क्यों है समझना everybody. तो ना मोमेंट ऑफ इनर्शिया, फर्स्ट पॉइंटर, लेट्स राइट की पॉइंटर्स अबाउट इट. इट इज जनरली रिप्रेजेंटेड बाय द लेटर कैपिटल आई. आई रिपीट, मोमेंट ऑफ इनर्शिया इज जनरली रिप्रेजेंटेड बाय कैपिटल आई. क्या है ये, व्हाट इज डज इट मीन, लेट अस अंडरस्टैंड. है तो फर्स्ट स्टेटमेंट यू ऑल विल राइट, इट इज एनालॉगस ऑफ, इट इज एनालॉगस, or it is analogous to mass. It is analogous to mass. What does that mean, sir? So let us take this question with Vasu. Vasu, you have a truck or suppose a car. Say car has a weight of m kgs, okay? And then you have, this is a toy car, and then you have one big truck, and this truck has a weight of 1000 times of the mass of the 1000 times the mass of the toy car. Which do you think is easier for you to push if you are pushing this from here? So suppose you are here, Vasu, and you're trying to push this toy car. So is pushing a toy car as an easier thing to do, or pushing a heavy truck is easier thing to do? Vasu, depends from person. Huh, Vasu?
Toy car.
Toy car is easier. And which is harder to do?
The real one.
Why?
The real truck.
Why do you think is that the case?
Sir, because its weight is more.
Yes. Which means that linear motion is somewhere influenced by the mass of the object. Am I correct?
Yes, sir.
The ease to do linear motion, the ease to do linear motion is very much proportional to the value of mass. Similarly, the way linear motion is impacted by mass value, वैसे ही in rotational motion, what makes it easy or hard is the concept of inertia or moment of inertia. Therefore, I have written it is analogous to mass, which means that if a body has high moment of inertia value, has I high, or the moment of inertia value is high, it will be difficult to rotate that body. The more challenging it is to rotate that body. So it is challenging to rotate it. So rather than writing this way, let's write it in a small column wise format. So quickly everybody will make a short column and let's write it here. If I is high, in that case the rotation will happen with the challenge. Rotation will be a challenge. Whereas अगर I value is very low, if I value is very low, then rotation would happen very easily. ठीक है? So this is just an idea. ये सिर्फ एक छोटा सा आइडिया है कि requirement of I कम है या ज़्यादा है can influence your rotational motion. But ना actually in real time इसका reverse होता है. क्यों होता है? I'll tell you all. But for now you all can just, if you all want, you can delete this also. अभी ना क्योंकि तुमको ऐसे बहुत सारे real case में scenario बताऊंगा जहाँ इसका उल्टा भी होता है. तो at least you can write this कि moment of inertia influences the ease of rotation. Simple. Moment of inertia influences the ease of rotation. कितना easy या मुश्किल अभी समझ में आ जाएगा when we'll take some questions. Just write this down. Moment of inertia influences the ease of rotation. So this is one aspect of it. मतलब ये एक physical concept है. अब इसका mathematical approach let's see. Ease of rotation. कितना easy है किसी object को rotate करना? How easy is it to rotate any object, or how difficult it is determined by moment of inertia of that body. This is the physical significance or qualitative significance. Now let's delve into the quantitative part of it. So how do you define it? So there are different ways of defining it. Let us first take the simplest scenario, simplest moment of inertia. Let us assume that there is an axis, एक बड़ी सी axis. Let us say there is some axis. Axis मतलब about which rotation will take place. That imaginary line about which the rotation will take place. Assuming that this is the axis, this yellow color is the axis, the yellow color line, and now let us make that object which is going to revolve around this yellow color line. Let us make its orbit. Orbit is the imaginary path in which any body rotates. Suppose this is the axis and here is the body of mass m, which is placed at a distance r from the body. ये वाला distance is r, and this body is rotating. ये body is rotating in this imaginary path or the orbit. So this is the orbit, this is the axis. ठीक है? Orbit का मतलब the path in which this body will rotate. R is the radius or the perpendicular distance. You all will write perpendicular distance of the body from the axis. Perpendicular distance of the body from axis. And which kind of body is this? इसको बोलते हैं point mass. You all can write the heading. This is a point mass. That means we are assuming that whatever mass is present at one point. एक छोटे से point पे आपने सारा mass को concentrated कर दिया. You are concentrating entire mass at one singular point, and that is why such bodies are called as point masses. छोटे से point पर entire mass is concentrated. Now this mass is going around the axis, round and round and round and round. अभी everybody understand this very properly. ठीक है? Over here, dear learners. So now you are being told that what is moment of inertia for this system? Moment of inertia ka value is given as m into r square. Moment of inertia ka value is given as the product of mass. You all can write it here. Therefore we define here moment of inertia is equal to mass into its distance from the axis. का square. तो which somewhere tells to, मतलब इससे क्या समझ में आता है? What do you understand? कि the way in case of linear motion, only mass was determining how easy or difficult it is to linearly move a body. इसके unlike that, not only mass, but there is one more quantity which plays a very strong role in determining how easily or with how much difficulty will you be able to move a body. So it can be very clearly seen here that in order to move a body, not only mass but distance is also playing a role. On this, you all will write the next bonus point of the day, and that bonus point is moment of inertia depends upon the distribution of mass. सिर्फ mass नहीं, वो mass कैसे distributed है from the axis, कितना दूर है, कितना पास है, how close to the axis, how far away from the axis is the mass placed. that plays a very, very strong role in determining the value for moment of inertia. Quickly, everybody, write down the next pointer on the screen. Moment of inertia is very heavily influenced by the distribution of mass around the axis. It is heavily influenced by or depends on, जो भी तुम लिखना चाहते हो, right? Depends on or influenced by, depends on the distribution of mass. We need to solve a lot of questions, so everybody quickly write this into your copies. Take a distribution of mass around the axis, axis से कैसे distributed है mass, ठीक है, around the axis. Once you all are done, Jesse, if this part is done, everybody will raise their hands, all the Zoom viewers. Yes, and the YouTube viewers can say, yes, sir, we are done. We'll go to the next page. Come on, everybody. Depends upon the distribution of mass around the axis. Done, everybody. Come on. Let me know by a raise of hands. Hands already raised. You can bring your hands down. Once you all are done, hands down kar lena. Okay. If you want me to just move a little upwards, I can. And anybody who is yet remaining to write this, isko likh lo quickly and bring your hands down. Itna part is done. Chalo. When point number 1, 2, 3 are done, everybody will raise their hands. We need to solve some good amount of questions in today's session. Okay, so Aanchal has completed Vasu, Aryan, Ronit, Makesh and Ridhima writing. Once you all are done, just bring your hands down. Okay, great. Aanchal has completed. Makesh has also completed. Good. Ronit has also done it. Superb. Okay, everybody has done it now. Ridhima, yes, take a screenshot. 5, 4, 3, 2, 1. Let's go to the next part. Okay, now here comes the next part. Come on, everyone. So abhi point number 3 and 4. Actually, this was 4. I've written 3. It's okay. So everyone, let me know once you all are done. Jaldi se. Write this part and raise your hands. Ye wala part is done and there in your copies, raise your hands. Let's solve questions. Jitna solve karoge na, the more you will solve, you will see the better you will become in that topic. Don't just read theory, solve karo. Read from H.C. Verma, solve from D.C. Pandey. Read from H.C. Verma, solve from D.C. Pandey. This should go in a cycle. ठीक है. Done? Okay. Everyone, kindly raise your hands once this part is done. सबकी copy में. Ronit has completed. Okay. Aryan has completed. Makesh has completed. Ridhima, Aanchal, Vasu. Take a screenshot. 5, 4, 3, 2, 1. Here is your question coming up on the screen. Okay? Now, the question says again, you're being given with an axis. I'll draw the axis here. Okay, so here is your axis given. You're being told that there is a mass which is placed at a distance of, say 1 centimeter. है ना? This mass is 100 grams. I repeat, this mass is 100 grams placed at a distance of 1 centimeter from the axis. You need to tell me what will be the moment of inertia in SI units. इसके ऊपर भी will take a question. What is the SI unit? What is the dimension, etc. But that will come later. अभी सिर्फ SI units में try to report the value for moment of inertia. Poll शुरू करते हैं everybody. Come on, everybody. I'll write down the options here. ठीक है, everyone. You start off with the polls. तब तक तुम लोग you all first go with the calculation. जल्दी से. I'm putting the values here on the screen. You all will meanwhile go with the calculations. है ना? चलो, everyone, quickly. We'll raise the level. 0 से ऐसा उठेंगे. You'll say, अरे वाह सर, कहाँ पहुँच गए? कहाँ से शुरू किए थे? जल्दी से. Yes. Everyone will start writing this into their copies and then we'll go ahead with the polls. So here are your options on the screen. First one is 10 ka power minus 3, 10 ka power minus 5, 10 power minus 7 or none of these. ठीक है? SI unit में, SI unit, please remember you have to give the answer in SI unit. So starting with the poll, dear learners, here is your poll coming up on the screen. Already I've given a lot of time, so take not more than 30 seconds. This question is very easy. Everybody can do it. Let's start the poll over YouTube also. Dear audience, dear learners, everybody, let's start. सीखते रहना, solve करते रहना. We have to keep moving, keep solving. Everyone, chalo. Yes. Good. 18 seconds already done. 10 more to go. Okay. 20 done. Okay, 6 more seconds to go. Okay. Now, I'm closing the poll, everybody. Alright, cool. Sharing the results with all of you. Okay, there is a tie between option number A, B and D. Let us see how many of you have done it correctly. ठीक है, simple question, कोई दिक्कत नहीं थी. Let us quickly solve it with Aryan. और let's solve this with Ridhima. Ridhima करोगे साथ में solve? Ready? Ridhima?
Yes, sir.
चलो, कैसे करेंगे बताते जाओ सब लोगों को. Yes, Ridhima, over to you. हाँ, let
Sir, it
everybody.
will first be mass into radius का square is inertia. तो पहले we will do m into r का square, that is 100 into 1 का square.
एक बात बताओ रिधिमा, इफ आई वांट टू कन्वर्ट ग्राम्स इनटू केजी, व्हाट इज द मेथड फॉर इट? डिवाइडेड बाय 1000 या मल्टीप्लाइड बाय 1000?
Multiply.
डिवाइड बाय 1000. अच्छा,
पर वो तो ग्राम है ना.
सेंटीमीटर. हाँ, इसीलिए तो. अच्छा, उसी तरह से 1 सेंटीमीटर को वी वांट टू कन्वर्ट इनटू मीटर. डिवाइडेड बाय 100 या मल्टीप्लाई बाय 100?
Divide.
वेरी गुड, सुपर. अच्छा, अब 1/10 इंटू 1/10 का पावर 4, करेक्ट रिधिमा? which becomes 1/10 का power 5, which is equal to 10 का power minus 5. वेरी गुड. चलो एवरीबडी क्विकली पुट दिस डाउन. रिधिमा, अगर कन्वर्जन में कोई इशू हो क्लास के एक बार रुक के मुझसे पूछ लेना, ठीक है? चलो ओवर टू यू एवरीबडी. इफ दिस इज क्लियर, क्विकली ब्रिंग योर हैंड्स डाउन. वी नीड टू सॉल्व गुड अमाउंट ऑफ क्वेश्चंस. जल्दी से. सिंपल क्वेश्चन था. वी कन्वर्टेड सिंपली हियर ग्राम इनटू किलोग्राम बाय डिवाइडिंग इट बाय 1000 एंड सेंटीमीटर इनटू मीटर बाय डिवाइडिंग इट बाय 100. वंस यू ऑल आर डन राइटिंग, ब्रिंग योर हैंड्स डाउन. Achal and Makesh have completed. Okay, now Aryan has also completed. Vasu is writing. Ridhima, okay, Vasu is completed. Ridhima and Ronit, yes, take a screenshot. Ridhima and Ronit, we'll go to the next question. 5, 4, 3, 2, 1. चलो, super. अभी ना one more logic is ये logic भी है and this is a pointer also. You need to tell me what is the SI unit. What is the SI unit for moment of inertia? What is the SI unit for moment of inertia? Moment of inertia. Yes, here is your poll coming up on the screen, dear learners. First one, kg meter. Second one, kg per meter. Third one, kg meter square. Fourth one, kg per meter square. Let's start with the poll, everybody. Simple question so that you all can do it. Go ahead, over to you, my dear learners. Yes. Okay, meanwhile, I'll also launch the poll over YouTube. Okay. Now the poll is also coming up on the YouTube, dear learners. Go ahead and here is your poll. Chalo, everybody. Yes, you all can do it, can do it. Come on, come on, come on. Try, try, try. Yes. So 5, 4, 3, 2, 1. Okay. 80% of those answering have answered it correctly. Very good. Very happy to see that. बहुत ही बढ़िया. चंगा सी है ना? शानदार. Very good. So अभी let's take the correct answer. Correct answer is option number C. Can I see quickly here on the screen how many of you could answer it correctly? Yes, Makesh could answer it. So could. Can you raise your hands, dear learners? जल्दी से. Makesh and Achal could answer it and. Raise your hands अगर आंसर सही आया तो, dear learners. Okay, Aryan and Ridhima, Ronit, Vasu. Let's solve this with you, Vasu. So Vasu, tell me what's the formula for moment of inertia? I is equal to m into r square, correct, Vasu?
Yes.
What is m? Mass.
Yes,
And what
sir.
is r? Distance. तो
Yes.
mass का unit is kg and distance का unit is meter.
Meter.
So kg into meter square. Simple. Vasu, are you
Yes.
clear?
Yes.
Okay, super. Very good, Vasu. Ronit, are you clear, Ronit?
Yes, sir.
Okay, so write this down into your copies, Vasu and Ronit. Then raise your hands where we'll move to the next question. Yes, come on, quickly. Done. I'll go for a reverse counter. 5, 4, 3, 2, 1. Okay, अब आ जाते हैं अगले सवाल पे. Let's take the next question. Here is your next question on the screen, dear learners. है ना? सवाल ध्यान से सुनना है everybody. Very beautiful question. So question tells you, question आपसे कहता है that now you need to tell me what is the dimension for moment of inertia. I repeat, what is the dimension for moment of inertia? These all kind of questions are asked in the exams. ठीक है? It is not simple. मतलब simple है, but still they are asked in the papers. So your options are here, है ना? M, L, T minus 2 or M, L2, T0. Option C is M0, L0, T2 or none of these. Simple question. Dear learners, poll शुरू करते हैं. Everyone, I'll also start the poll over YouTube. So dear learners, be ready. Okay, over to you everybody. Take not more than 30 seconds. Yes, chalo. Quickly. We'll also start the poll on YouTube. Yes. Okay. Launch the poll both ways on Zoom as well as YouTube. Go ahead learners and take the best advantage and of the polls. And सीखो. Polls के जरिए you will have the habit of सीखने का, है ना? So सीखते जाने का everybody. Come on. Yes. गलती होती है, it's good, है ना? It's not a bad thing to do mistake. It's a good thing to do a mistake. सीखते जाना. Everybody keep learning from every mistake that you do. Okay. Done. Everyone, chalo, super.
Sir, I did the wrong one in poll. I have sent you the chat.
It's okay. All right. So 80% of those answering have answered it correctly, and let's also see the chat. So Anshul is Ridhima is saying option number B. Okay. All right. ठीक है. Cool. Everyone, let's have a look into the correct answer. Which one is the correct answer here? So correct answer is option number 1 minute. Everyone. Quickly, just a second. My screen has been erased. Okay, now it's here. ठीक है. So the correct answer is option number B. Good. How many of you could answer it correctly? Can I have a quick raise of hands from all of you? Or bring your hands down if you all are clear. देखो simple है ना, kg meter square. तो kg meter square. kg is the unit of mass. तो m. Meter is the unit of length. तो L का square and T का, there is nothing in time, so T का power 0. So dimension is M L2 T0. Okay, so Vasu and Ronit, are you now clear? Let me know. Ronit, is this clear to you, Ronit?
Yes, sir. Sir, मैंने mark नहीं करा था.
कोई बात नहीं, it's okay. Clear है ना, Ronit? You're clear on this? Okay, Vasu, how are you on this? Clear?
Yes, sir. Yeah, I gave the pointer.
Okay, please take a screenshot, everybody, if required. 5, 4, 3, 2, and 1. Let's go to the next poll. ठीक है. Now, अभी ना there is something called as composite moment of inertia. Composite moment of inertia मतलब what if there are more than one bodies? अगर suppose एक नहीं, एक से ज़्यादा bodies हैं, then what will happen? Then what to do, sir? ना? So in that case, we talk about composite moment of inertia or moment of inertia for more than one bodies. So you all will write here, moment of inertia for a system. Moment of inertia. I'll write MOI. ठीक है? Moment of inertia of a system. So suppose the system में भी ना दो तरह का distribution is there. One is called a continuous system. Continuous मतलब all the particles are stick together. The way we have done in a center of mass, if you all can recall, है ना? So one is continuous system. Other is discrete system. So what is discrete, what is continuous, I'll let you all know in detail. अभी suppose you have a rod, ठीक है? तो rod is a set of lot of particles, infinite particles जुड़े हुए हैं rod में. So it is a continuous system, very close to each other. Similarly, suppose I have a disc, ठीक है? I have a ring. All these are continuous systems. Ring बहुत सारे particles से मिलकर बनती है. A ring is formed with many particles together. So ring, disc, rod, all these are examples of, है ना? Suppose this is a disc. So ring हुआ, disc हुआ, rod हुआ, है ना? Here we have a ring, ठीक है, and cylinder, many other, ठीक है? All of these are continuous systems. So discrete system क्या होता है? Discrete means you have one system, and you have 2 pointers, है ना? Or maybe you'll have 3 different balls here, ठीक है? Now you are considering them as point masses, or maybe you are given 5 different balls in a system, and you are told कि अभी 6 different balls in a system, and they say इनका total moment of inertia निकालिए. So this is the difference between continuous and discrete moment of inertia. तो let's see इसका कैसे calculation होता है, ठीक है? Everybody, I'll write down the formula here. It's very simple. So अभी moment of inertia for one body was mr square. Suppose I have different bodies like this. Let us distribute them along the axis. अभी यहाँ पे I have body number 1, body number 2, body number 3, body number 4, body number 5, body number 6. So what do we do? हर एक point का we take the perpendicular distance like this from the axis. Suppose let us name them as masses m1, m2, m3, m4, m5, m6. ठीक है, 6 different masses assuming, okay, and each one has a distance called say r1, r2, है ना, r3, r4, r5, r6 from the axis. Axis से मान लो हर point का perpendicular distance is like this. Simple funda is just add their moment of inertias. Moment of inertia ना एक scalar quantity है. If you all want, you all can write that also. ठीक है, so this is point number 5. I think that was point number 4 that we had taken यहाँ पे. ठीक है, this was point number 4. ठीक है, you all can make this correction if you haven't already. ठीक है, एवरीबॉडी क्विकली कम ऑन जल्दी से लिखते चलो, नोट्स बनाते चलो, बेहतरीन और शानदार से बेहतरीन नोट्स. यस एवरीबॉडी, सो मोमेंट ऑफ इनर्शिया इज अ स्केलर क्वांटिटी. प्लीज रिमेंबर, मोमेंट ऑफ इनर्शिया इज अ स्केलर क्वांटिटी. ठीक है, तो स्केलर क्वांटिटी के लिए देयर इज नो डायरेक्शन, इसका कोई डायरेक्शन नहीं होता. दैट ऑल्सो यू ऑल कैन राइट एज अ पॉइंट इफ यू वांट. यू ऑल कैन टेक दैट एज पॉइंट नंबर 6 ओवर हियर. ठीक है, मोमेंट ऑफ इनर्शिया का डायमेंशन इज m l2 t0. ठीक है, m1 l2 t0 एंड इसका यूनिट, ठीक है, SI यूनिट इज गिवन बाय SI यूनिट इज kg मीटर स्क्वायर. छोटी चीज है, दीज आर सिंपल पॉइंटर्स बट यू ऑल शुड नो अबाउट इट. ठीक है, SI यूनिट एंड डायमेंशन को अपन ने यहाँ पे लिख दिया. नाउ discrete body के लिए what did I say? Simply add कर दो. Whenever there is a scalar quantity and you want to calculate the total value, so total value is simply given by the formula. Let's write it here. It is simply given by the formula. Total is equal to I1 plus I2 or I system. You can also write that. I system is equal to I1 plus I2 plus I3 plus I4 प्लस i5. सिंपल. ठीक है, लेट्स सब्सटीट्यूट इट हियर. इसको सब्सटीट्यूट करते हैं. ठीक है, एवरीबॉडी हैव अ लुक. तो वी विल हैव दिस एज, आंचल क्या हो जाएगा बोलो. यस आंचल, m1 r1 स्क्वायर प्लस m2 r2 स्क्वायर प्लस so on until the 6th particle. Correct आंचल? अभी you all can do this. हाँ, you all can do this minor corrections. Good. तो until the last particle. Correct आंचल? Right? Okay. अभी इसके लिए do you all remember a short form? I had taught you all a short form also in terms of summation. इसको you all can write it as summation of mi ri whole square, right? जहाँ पे I is from 1 to n, है ना? अगर suppose there are n particles in the system, suppose तो you will go until mn rn square, correct? mn rn square. So for n number of particles, this is the short form of moment of inertia. The same thing we did while calculating center of mass also. Similar notation. अभी क्या होता है when there are similar kind of terms coming, तो हम एक ही term लिखते हैं. This sign is called summation sign or sigma sign. For those of you who have forgotten, this is called sigma sign or summation sign. You all can refer. आप क्या refer कर सकते हो if you have forgotten? You can refer my notes from center of mass. सेंटर ऑफ मास का नोट्स एज यू विल रेफर, ये याद आ जाएगा एवरीबॉडी. क्विकली इफ यू ऑल आर क्लियर ऑन दिस, रेज योर हैंड्स जल्दी से. हाउ मेनी ऑफ यू कैन रिकॉल कि सिग्मा मींस समेशन, तो यहाँ पे mi स्क्वायर समेशन लिख दिया, मींस यू आर गोइंग फ्रॉम 1 to n एंड देन एडिंग फ्रॉम 1 2 3 4 5 6 7 8 9 until n टर्म्स. चलो, आर्यन इज क्लियर, आंचल इज क्लियर, अदर्स हु आर क्लियर कैन आई हैव अ रेज ऑफ हैंड्स. जिसको डाउट हो पूछो. रिद्धिमा, यस आस्क मी. Is this clear रिद्धिमा? कोई डाउट है? हाँ बोलो. यस रिद्धिमा, ओके क्लियर है. रोनित, एनी डाउट्स प्लीज आस्क. यस रोनित, ओके क्लियर है. वंस यू ऑल आर डन राइटिंग दिस इनटू योर कॉपीज लेट मी नो. ओके कूल. आर्यन राइट. एवरीबॉडी फर्स्ट दिस पार्ट इनटू योर कॉपीज एंड देन यू कैन ब्रिंग योर हैंड्स डाउन. जैसे लिख लोगे ना. अच्छा, लेट मी ऑल्सो कन्वर्ट दिस, थोड़ा सा कन्वर्जन कर देते हैं. अभी आर्यन, डू यू रिमेंबर, अभी मान लो यू हैव अ रॉड हियर. ठीक है, लेट्स टेक अ स्मॉल रॉड हियर. ठीक है, तो हम लोग क्या करते थे जब भी कभी हमको कंटिन्यूअस सिस्टम होता था तो इंटीग्रेशन करते थे. याद आ रहा है आर्यन? तो क्या करते थे, वील स्मॉल एलिमेंटल मास. याद आ रहा है क्या करेंगे? वील अज्यूम देयर इज अ स्मॉल एलिमेंटल मास, से हैज अ मास ऑफ dm एंड लेट दैट बी एट अ डिस्टेंस ऑफ कितना, r फ्रॉम द एक्सिस. फिर वी यूज टू क्या करते थे हम लोग, सपोज इस छोटे से मास का छोटा सा मोमेंट ऑफ इनर्शिया निकालते थे di. व्हाट इज द वैल्यू ऑफ di विल बी, अभी व्हाट वाज द फॉर्मूला फॉर एक पॉइंट मास के लिए फॉर्मूला क्या होता था? I was equal to m into r square. तो एक छोटे से एलिमेंट के लिए वी आर कंसिडरिंग अ स्मॉल एलिमेंट, वी आर कंसिडरिंग अ स्मॉल एलिमेंट. तो इस स्मॉल एलिमेंट के लिए लेट अस टेक मोमेंट ऑफ इनर्शिया इज डी आई. डी आई क्या हो जाएगा, जैसे I इज इक्वल टू एम आर स्क्वायर. तो ऑन द सिमिलर नोट व्हाट शुड बी द वैल्यू फॉर डी आई, आर्यन? डी एम इंटू आर स्क्वायर, करेक्ट?
Yes, sir.
Let's write that. After you have this, अभी हम क्या जानते हैं, we can integrate on both sides. क्या कर सकते हैं आर्यन? इंटीग्रेशन ऑन बोथ साइड, जिससे पूरे सिस्टम के लिए हम ऐसा करते जाएंगे, इसके लिए भी, इसके लिए भी, इसके लिए भी. we'll take different particles and for every particle we'll multiply उसका mass dm into उसका distance r, mass dm into उसका distance r. So you'll do this for all the particles and you will get the total moment of inertia as I is equal to r square dm. Why am I telling this so much in detail? You will see in the papers, JEE papers, mains and advanced 2019, 2020, almost every year they are asking you questions of this part in your papers. ठीक है? So I want you to go very perfectly with your paper. इसी वजह से giving you so much detailed analysis. Quickly everyone, यहाँ से start writing. Once you all are done, kindly raise your hand. फिर उसके बाद we will move ahead. Once you all are done, let me know so that we can move ahead after this. Over to you everybody. Yeah. Dear learners, come on, come on, come on everybody. Yes, go ahead. Once you all are done, let me know. Sure. Once you all are done, everybody will bring their hands down. Okay, Makesh and Vasu have done, completed. Okay, Aryan has completed it. Good, good, good. All right, many of you have completed. Take a screenshot. I'm moving to the next screen. 5, 4, 3, 2, 1. Okay. Now this part. Once this part is there into your copies, you all can again raise your hands. Yes. You all can again raise your hands. I put all hands down. Yes, sure. Everybody. So Makesh has completed it. Then raise your hands once this part is done. So isko na you all can put into brackets. Ye wala part can come in brackets. This wala part. Moment of inertia in a continuous system and moment of inertia in a discrete system. Discrete and continuous systems के लिए moment of inertia. This is for continuous system. This is for discrete system. Once you have completed, let me know. Let's start solving questions on this. अभी इस पे we'll solve questions. Yes. Okay. Raise your hands once you all are done. Makesh has completed. Aanchal, Ronit has completed. Bring your hands in the raised position. Ridhima, Aryan and Vasu, once you are done, let me know. Done. Take a screenshot. 5, 4, 3, 2, 1. Done. Everyone. Chalo. Okay. Now, ठीक है? Understand this question. Very simple. You are being told that there are two bodies over here. I'll make first an axis. Let's say this is an axis. Okay. Now let's make the coordinate system. यहाँ पे we'll make a coordinate system like this. Start making, ठीक है? Make along with me. Now you have this axis passes through the point a comma 0. A comma 0. You have two masses. One is placed at origin. This is mass m, ठीक है? And another one is placed at a point 3a comma 0. ठीक है? 3a comma 0. This also has a mass m. I repeat, यहाँ पर this is the axis, ठीक है? Which is a straight axis, ऐसा vertical axis passing through the point a comma 0. There are two masses. One is placed at the origin, ठीक है? ये origin है. This is y axis and this is x axis. Question says that you need to calculate the total moment of inertia for the system about the given axis. ये दोनों masses इसके आसपास ऐसे rotate करेंगे, ठीक है? Now this is the radius for the first one, 0 से, suppose let us name these points as A, B and C. So these three are the point. There are 3 points. Are from B, axis is passing, and on A and C there are masses placed. You need to calculate total moment of inertia for this system. I'm going to write down the options here on the screen. You all can go ahead with your calculations. Pehle, let's take this from Vasu. Vasu, tell me, is this a discrete system or a continuous system? What do you think? 2 different masses placed at 2 different points. Discrete or continuous system? Discrete, very good. So what will we have the moment of inertia as summation of mi ri square, correct? For
Yes.
I is equal to 1 to 2 because there are 2 particles, and that can be written as m1 r1 square plus m2 r2 square. Correct? Chalo, go ahead with your calculations, everybody. I'm launching the poll for everybody here on Zoom as well as on YouTube so that you all can go ahead with your polls. Yes, come on, go ahead, dear learners. You all can do it very well. Come on, try. And I'm sure you all will do it very properly. ठीक है? चलो, try करो क्योंकि आगे बढ़ने से ही काम होते हैं ना. When you try, you become successful. So go ahead and make your attempts. Come on, I know you all can do it. You all are my brave learners. My learners are very brave. They are becoming better every day. My students, my learners are very brave. They are becoming better every day. Good. Chalo, everybody, come on. Yes. So I will just make sure that you are taking the correct distances. है ना? This is of course R1. I'm giving you all a hint. This is R1. ठीक है? And this is R2. Remember, ये R2 नहीं है. This is not R2. This is the position of that point. 3A का meaning क्या है, Aryan? 3 is ये वाला distance. Am I correct, Aryan? Distance from the origin. Aryan, correct?
Yes, sir.
3 is the distance from the origin. ये R2 नहीं है. This is R2. Distance from the axis is R2. So if somebody is taking 3A as R2, please be aware. Don't do that mistake. पहले ही एडवांस में बता दिया आपको. Given in advance the value ताकि आप गलती ना करो. So that you all don't do the mistake. Come on, चलो, everybody, yes. You will go ahead with your calculations. Come on, dear learners, here are your options on the screen. First one is 5 ma square. Second one is 10 ma square. Then you have 7 ma square, and then you have none of these. So here is your poll starting on the screen. Okay, dear learners. So options are starting now. Come on, yes. Come on. जल्दी से कोशिश करो, बिकॉज कोशिश करने वालों की हार नहीं होती, लहरों से डरकर नौका पार नहीं होती. राइट, सो यू ऑल विल गो अहेड एंड ट्राई बट डोंट क्राई. ओके, यस, waiting for you everybody. Good, 20 seconds are done. 9 more seconds to go. 5, okay, 4, 3, 2 and 1. Okay, all right, so good, very good. 80% of those have answered it so properly, so correctly. Good, very good, excellent. क्या बात है, dear learners. I am so proud of you all. I am launching a poll on YouTube also. Meanwhile, I'll start explaining this to all of you, so my Zoom viewers can see the correct answer. So I'll not reveal it for the YouTube viewers right now. ठीक है, let them do this poll. Meanwhile, let's take this with who will tell this question to me. जल्दी से, Aridhima, can you please raise your hands? जल्दी से, yes. जल्दी से Ridhima, can you please keep your hands raised? Okay. Now, who can tell this question to me? Keep your hands raised. Those who are not willing can bring their hands down. Yes. Makesh, would you like to try? Makesh,
Yes,
would you
sir.
like to try? Chalo, tell me. How to solve this question, Makesh? Yes. Over to you.
Sir, here we can take as A comma 0 as axis.
No, not like this. What is asked? Tell us the question and then the approach. Makesh. Yes.
Sir, it is asked to find the moment of inertia of this
Moment of inertia
system, sir.
system, or just for A, or just for C, or for both A and C?
For the whole system, sir.
For the whole system. Okay. How many particles are there in the system?
2, sir.
2 particles are there. Okay. And what what kind of system is this? Discrete or continuous system?
Discrete, sir.
Discrete, sir. How to solve this question? Makesh. Yes.
Sir, we need to find the radius of this.
Radius or distance of each particle from the axis, okay?
So distance, sir.
Yeah, distance of A from the axis. What will be this distance from 0, 0 to A, 0? What will this
Yes,
distance
sir.
be equal to?
R1
A.
equal to A, sir.
R1 is equal to A. Very good. For the first particle or the particle at A, Makesh is saying that, sir, the distance of this particle is A. Okay. Then what about the second particle C, Makesh? What is
R2 equal to 2A, sir.
How come it's written 3A here and you are
No,
saying
sir, he taking A comma 0 as axis, sir.
Oh, A comma 0 is the axis. So you need to take the distance of this particle from the axis properly.
Sure.
Sure. Okay. So we know that whenever I write A comma 0, इसका meaning क्या है? इसका meaning it's distance from the origin. Origin से distance is A. And when I write a 3A here, it means that the distance of this point from the origin is 3A. And I am supposed to take this distance BC. This is 3A, this is A. Distance BC will be 3A minus A, that is 2A. That is how Makesh told us ki, sir, R2 is 2A. Am I correct, Makesh?
Yes, sir.
Yes. Okay, great. What are the masses given by the
M, sir, for both.
M. For both of them, M. Okay. Now, what is the formula? Can you once again read it out loud, Makesh? Formula for a discrete system? Yes, Makesh.
Sigma square I
Read out.
equal to 1 M by RA square, sir.
Once again, read out the formula. I discrete is given by, yes, Makesh,
Sigma M by RA square.
which is M1 R1 square plus
M2 R2 square.
M2 R2 square. Very good. Now let us substitute. Easy now, right, Makesh?
Yes, sir.
M into A square plus M into 2A
2A
square.
the whole square.
Okay, how much will it become equal to? Yes,
MA
Makesh.
square plus 4MA square.
Okay, so 4A square, 4MA square plus MA square. How much is it coming as equal to?
5MA square.
5MA square. Let us quickly revise it, my dear learners. What did we do? We had two different point masses which are placed at two different positions, R1 and R2 respectively. We were supposed to calculate what is the value of total moment of inertia for this system. We took the formula that we just learned and calculated their respective distances from the axis. Substitution kiya to reach the final answer. So everybody, are you all clear? The correct answer is, Aanchal, the correct answer is option number?
Option number A.
Option number A. Very good. How many of you could get the logic to the question? कितने लोगों को key mind में समझ में आया? Ridhima, can you please raise your hand, Ridhima? Yes, Ridhima, can you? Okay. Now everybody, if you're clear, bring your hands down. Yes, those who are clear, please bring your hands down. Come on, come on, come on. Over to you, dear learners. Are you all clear? Is it simple? समझ में आया? Bring your hands down if this is clear. Yes, Vasu. Yes, Ashal. Please let me know your queries. Okay. Yes, Anshul, bolo. Clear hai. Okay. So put this down into your copies and then bring your hands again in the raised position. जैसे ही हो जाएगा, everybody will put it in their hands raised position ताकि we'll continue. रिद्धिमा कुछ कहना चाहती है? बिल्कुल.
Yes, sir. Can you show the question? Just a minute.
Sure. हाँ. Yes, Riddhima,
Yes, sir.
Go ahead. Done. Okay. So everybody, I hope you all are done with the question. If not, take a screenshot. 5, 4, 3, 2, 1. All right. अभी ले लेते हैं solution once again. 5, 4, 3, 2, and 1. Okay. Chalo. Everyone, let's go to the next question then. Let's go to the next question, है ना? So now अभी you will find कि इस तरह के questions को you all will be able to do it very properly, ठीक है? अलग-अलग तरह के questions can come, है ना, to all of you and you all will do it very properly. I'll ask one more question, चलो. This question is from the concept of moment of inertia for a rod. Let's try to derive it, है ना? Everybody, let's try to derive it. I will take the axis at the end of the rod. Let us take the axis at the end of the rod. So I will take the axis over here like this. Okay. Aryan, ready हो करने के लिए इस question को? Yes, Aryan.
Yes, sir.
Let's take this point as origin or 0, 0. You all can give the heading moment of inertia for a rod. You all can give the heading moment of inertia for a rod. Moment of inertia for a rod. Or better, write uniform rod for continuous bodies. ऐसा लिख लो. You all can give the heading for continuous bodies. Continuous bodies क्या होती हैं आर्यन? First of all, tell us that. What are continuous bodies? Continuous मतलब Aryan, what is continuous? All the points are connected to each other. जैसे यहाँ पे the points were discrete, spread out थे. ये points कैसे थे? Spread out थे. They were spread out. And when the points are not spread out, rather they come together to form one solid body, one rigid body. तो उसको अपन क्या बोलेंगे आर्यन? We'll call that as a continuous body. Is that point clear अपन को आर्यन?
Yes, sir.
What is a continuous body बोलो? All the points are
All the
placed
points are
very
connected.
all the points of the body or the constituent particles from which the body is made, they are placed very very close to each other. Such a body is called as a continuous body. Clear, Aryan?
Yes, sir.
Okay, चलो. Now let's start solving it. तो अभी क्या करते थे? What was the first step? हमने क्या किया था in the last time? क्या सीखा था? How to calculate for a continuous body? We used to take a small elemental mass. ऐसा? Yes.
Yes, sir.
So let's assume that there is a small elemental mass जिसका thickness is dm. Am I correct? जिसका thickness is dm. Let's take its length from the or its distance from the axis is x. Distance is x, and let us take its width as dx. या तो you can take like that, या तो you can write an r here. It's completely up to you all. Whatever you all want to do, you all are free to. So यहाँ पे let us write this distance is x and the thickness is dx, or r also, whatever you all wish you can do. What was the formula that we learned for point mass? Tell me, for a point mass what was the
I equal to mr square.
so एक point, so everybody एक बात याद रखना, ठीक है? Anything can seem to be complex, बिल्कुल दिक्कत नहीं है, कोई बात नहीं, it's good. Try to make it as simple as possible. जितना simplify कर सको, better is, right? I repeat, whenever anything seems complex, break it into parts and make it easy. Here also there is a big rod. I want to simplify its moment of inertia का calculation. Let us break it into parts. छोटे parts में let us break it. Or let us assume that this entire big rod is made up of many elements, out of which this is a small element. So what you are doing, you are writing here, consider a small element. Consider a small element. Acha, this everything is a theory thing, is just for one time, okay? Next time you will have to take it for granted कि तुमको लिखना ही है copy में. Everybody has to write this in their copies. Let us take a small element. Let us take a small element of mass dm and thickness, your width as dx at a distance of x from the axis. Everybody will kindly write this down into their copies. Okay, abhi point mass ke liye quickly, Aryan, what was the formula? Yes,
I equal to mr square.
mr square. Very good. So abhi for this point mass over here, dm, what should be the moment of inertia?
Dmx square.
So the small moment of inertia for this element, कौन सा? Moment of inertia for the element. Moment of inertia for the element should be di, है ना? And di should be equal to how much? Dm into r square. Or here we have taken r as x. So what can we write? Dm into x square. Correct, Aryan ji? Yes?
Yes, sir.
Okay, suppose the total mass of the rod is m. क्या है? Total mass of the rod is m. And suppose its total length is L. कैसी, Aryan? बोलो, total length is L. Now, do we remember, Aryan, that if there is any rod, suppose it is uniform in nature. कैसी है? Suppose, let us take two cases यहाँ पे, uniform and non-uniform. Now, we'll make two cases here. Let us take two cases here. One case is that the rod is uniform. Uniform का मतलब क्या होता है? Aryan, mass per unit length constant or variable?
Sir, constant.
Constant. So when I say the rod is uniform, it means that mass per unit length is constant. Or mass per unit length can also be written as mass by total mass by total length, or small mass dm by uska chota sa length dx. याद आया, Aryan? Yes?
Yes, sir.
So here this mass is dm and iska small length is dx, or total mass is capital M and total length is L. So when I say that uniform, अगर वो system uniform है, it means that mass per unit length is constant या variable, Aryan?
A constant.
Constant. Very good. Let us write that here. Similarly, you can also have second case where mass per unit length is non-uniform. Mass per unit length is non-uniform. इसका meaning भी समझो. It means that कि rod कहीं से हल्की है, कहीं से भारी है. I repeat. Suppose this part of the rod is made up of iron, and this part of the rod. Suppose everybody. I repeat. Suppose the first part of the rod is 1, second part of the rod is 2. This first part is made up of iron and second part is made up of wood. Aryan, tell me which part will be heavier and which part will be lighter? Aryan.
Sir, iron will be heavier.
So it means that this is a non-uniform rod or uniform rod then?
Non-uniform.
That is called a non-uniform rod. मतलब अलग-अलग part में the value of the masses will be different. That is called non-uniform with length. है ना, बिकॉज यहाँ पे इन दिस रॉड द मास डिस्ट्रीब्यूशन इज देयर अलोंग द लेंथ के अलोंग आपने मास को डिस्ट्रीब्यूट किया हुआ है, एंड बिकॉज द मास हैज बीन डिस्ट्रीब्यूटेड अलोंग द लेंथ, व्हेन आई से नॉन यूनिफॉर्म डिस्ट्रीब्यूशन मतलब अलग अलग लेंथ पर अलग अलग मास इज प्रेजेंट. सो राइट इट हियर एवरीबॉडी. सो नॉन यूनिफॉर्म. एंड नॉन यूनिफॉर्म का एक और मीनिंग होता है आर्यन, डू वी रिमेंबर, व्हेनेवर द मास पर यूनिट लेंथ विल डिपेंड अपॉन डिस्टेंस. याद आया क्या? डिस्टेंस या टाइम पर इफ दिस एनी क्वांटिटी डिपेंड, तब अपन उसको नॉन यूनिफॉर्म बोलते हैं. एग्जांपल के लिए याद करो, अगर इफ वी आर राइटिंग वेलोसिटी इज इक्वल टू 2 मीटर पर सेकेंड, तो ये यूनिफॉर्म वेलोसिटी, नॉन यूनिफॉर्म वेलोसिटी? आर्यन.
Uniform.
और इफ आई राइट v इज इक्वल टू 2x, तो ये यूनिफॉर्म या नॉन यूनिफॉर्म?
Non-uniform.
क्यों व्हाई?
Sir, velocity is dependent upon x.
हाँ, whenever space या time, whenever space and time पे dependency comes, that quantities or those quantities are called as non-uniform quantities. वो सारी quantities जो space और time पर depend करती हैं वो non-uniform कहलाती हैं. If everybody can recall this, कितने लोग इसको recall कर पा रहे हैं? Quickly raise your hands. How many of you can recall the quantities that are dependent on space and time are called as non-uniform quantities? जैसे acceleration is equal to 2x या 2t, that is non-uniform, या variable. There is another word for it, variable. How many of you can recall this from our already encountered topics in kinematics and mechanics? jaldi se raise your hands, dear learners. Yes, over to you everybody. Quickly. सबको याद आ रहा है? एवरीबॉडी प्रॉपरली एकदम अच्छे से? यस. ओके. सो लेट्स देयरफॉर राइट हियर इन द सेकेंड केस द डिपेंडेंस ऑफ मास पर यूनिट लेंथ ऑन x, क्योंकि यहाँ पे टाइम के हिसाब से we'll not take the variation, we'll just take the variation with regards to x. So here is your next step right here everybody. Suppose here this thing is a function of x. Function of x means it will depend on x. Example generally na this mass per unit length ko there is a word called linear mass density. I've already taught it before in class. Okay, you all can still write it again, those who have forgotten. There is a term called as linear mass density. Achal, what is linear mass density? Length per unit mass or mass per unit length?
Mass per unit length.
Good. Everybody write this down. Linear mass density, which is, we have already done this before. It is given as mass per unit length. Mass per unit length. There are different symbols you will find it is denoted with, but we will use the symbol lambda. We'll use the symbol lambda. And iska unit should be kg per meter or kg meter?
Kg per meter.
And what should be the dimension?
ml minus 1 t0.
So everybody quickly put this down. This is a physical quantity called as, जैसे we have mass, जैसे we have volume, जैसे there is a term called as linear mass density, which is mass का distribution per unit length or mass per unit length. Take a screenshot if you all want. 5, 4, 3, 2, and 1. I hope you all are done. Once you all are done, let me know. Come on, quickly. Jaldi se everybody will let me know once they are done writing by raising their. Okay, some hands are raised. Okay, I'll put all hands down. Raise your hands once you all are done, dear learners. Yes, come on. Yes, dear learners, go ahead and raise your hands once you all are done writing. Okay, cool, super. Okay, so now done now, everybody. Raise your hands or take a screenshot. Just take a screenshot. Get done with this. 5. This is there in your copies already. बहुत लिखा है आपको. You already know this. 5, 4, 3, 2, 1. Okay. Now, see, two cases, uniform and non-uniform. Non-uniform ka one of the examples is, suppose they'll write that dm by dx is equal to, say, dm by dx or lambda value, whatever you call it as. They'll say you lambda is equal to, say, alpha x, okay, where alpha is a constant. Alpha is a constant. Or they can also give you that lambda is equal to ax plus bx square. There can be different ways. ठीक है, इसके साथ बहुत तरीके से खेला जा सकता है. We'll quickly see some examples before we end the class. Everybody, take a screenshot. 5, 4, or write it down. Whatever. 3, 2, and 1. I hope you all are done. Okay, come on. So, अभी let's take a question. Simple question. फटाफट से, है ना? अभी this is mass. ठीक है. Abhi first we'll take question of uniform system and then we'll end the class. When we'll start it at 9 or 9:15, we'll continue it from there. Okay? So abhi this is this is the axis. यहाँ पे you have the axis and then you take a small point mass. Aryan, यही तरीका था. This was the method, Aryan.
Yes, sir.
Abhi what was the moment of inertia formula? I is equal to dm into r square whole ka under root. So in this case we had taken, this is dm. इसका thickness we had taken as dx and how far was it from the axis x?
Yes, sir.
This formula को we had written as, instead of r we can write x का square, r का square we can write x का square into dm. And what was the thing for uniform body? Suppose you are taking a uniform rod. So for a uniform rod, what can I say, Aryan? Mass per unit length constant or variable?
Sir, constant.
Constant. Let us take this as m by l. Suppose they are telling you mass is m and length of the rod is l. So dm by dx will be m by l, correct? Acha. By that we can write dm is equal to, bolo Aryan, m by l into dx.
Yes,
Right?
sir.
Acha. Abhi can we substitute that over here? इसको यहाँ substitute कर दें, Aryan. What
Yes, sir.
formula? Tell me. dm के जगह we'll write m by
ml by dx.
Okay, very good, superb. Acha, next step में, Aryan, what?
Sir, ml will come out and x cube.
Why will it come out? Tell everybody. Why will
Sir,
it come out?
constant.
Because here mass per unit length is constant. This is the case of a uniform rod. Uniform rod में mass per unit length does not change with time. Yeah, remains constant. Everyone, take a screenshot before we move to the next question. Yes, 5, 4, 3, 2, 1. Okay. Everyone, let's take the next question. Alright, so Aryan is saying ki, sir, we can take this m by l outside. Okay, what after I take m by l outside? What is the integration of x square then?
Sir, x cube by 3.
Okay, x power n ka integration. Vasu, do you know x power n ka integration is?
X power n minus 1.
No. Once again, have a look. Yes, read it out, Vasu.
X power n plus 1 by n plus 1.
Once again, Vasu.
X
Full
power
statement.
n
No,
plus 1 by
not just answer. Full statement, Vasu. Yes.
Integration of x power n is equal to x power n plus 1 by x power 1 n plus 1.
Good. So by same logic, we'll have x square ka integration is x cube by 3. Am I correct, Vasu? Now,
Yes, sir.
what are the limits for x? Achal, can we take this with you? Suppose this point, wherever we are taking the axis is 0, 0, because we are taking the x from here. So ये वाले point का coordinate should be how much? What do you think? L, 0 या 0, L? Achal.
L, 0.
L, 0. So can I see that here x is going from 0 to L, Achal? Can we see that? है ना? चलो, good. On that account, Achal, यहाँ पे what should be the limits for x? X का limit क्या लग रहा है आपको? क्या होना चाहिए? X का limit should be 0 to
0 to L.
L. Okay. So can we take that in the integration यहाँ पे? Can we take that, Achal?
Yes, sir.
Yes. So let's do that. Let's take the limit यहाँ पे. ऐसा. So this will become how much? M by L into
L
L
cube
cube
by 3.
minus 0 cube by 3. है ना?
Yes, sir.
Okay. After that, we'll have M L cube by L into 3, which will become how much?
ML square by 3.
ML square by 3. See, this is a very, very important derivation. Put this into your copies. We are going to solve more questions on this. But remember that what have we derived? We have calculated the moment of inertia of a uniform rod about one of its ends. हमने क्या derive किया? What have we just derived? I'll summarize it here. Write this into your copies, dear learners. We have derived that if I have a rod and through this rod an axis is passing like this. An axis is passing like this. We have just derived that the moment of inertia for a rod, I repeat, moment of inertia for a rod of mass m and length l. Suppose this rod has a length of l, and a mass given as m, then its moment of inertia about one of its ends is ml square by 3. Moment of inertia about one of its ends, about one end. This is the end, right? End portion of the rod. From there the axis is passing about the end. I is given as ml square by 3. Please remember, this is a very very important point. I'll put it into a bracket for all of you like this. I hope you all can see this, right? So put this into your copies. Let's quickly catch up at 9:15. You all can take a screenshot meanwhile. Yes, go for a screenshot. 5, 4, 3, 2, and 1. All right, we'll go for the next screenshot, everybody. Yes, here is your next part. Take a screenshot. 5, 4, 3, 2, 1. Anybody who requires more screenshots, go for it. 5, 4, 3, 2, 1. इस पे we are solving questions also, ठीक है, in the next session. So take care everyone. We all will catch up by 9:15. Until then, have your dinner and be back by 9:15. Bye bye everybody. Everybody here on Zoom may leave. If there is any doubt, you can ask. I'm there for all of you. Yes, dear learners, go ahead. All right. So done, everyone. Okay. Vasu, you can log out in case there is no doubt.
Okay, sir.
Yes. Okay. Good night. Yeah. We can catch up in 45 minutes. Okay.
Yes,
9.
sir.
Yeah. Okay.
Sir, do you leave the session open itself or do you close this one?
You can re-enter at 9:15. I'll keep it open, but you can re-enter at 9:15. For now, you can leave. Yes.
So what if I just leave it like this?
Sorry.
What if I just leave it like this?
No, I would suggest you can leave right now.
Okay.
You can come back. Yes. Don't worry, I'll let you in. Vasu.
Yes, sir. No, sir. Like genuine, sir. Just a doubt, like
Yeah. No, it's okay. You can.
curiosity.
You can actually log out and then you can log in by 9:15.
Sir,
Yeah. Okay. Bye bye. Take care.
bye.
All right, so very good evening once again to all our viewers out there. Hello, here, everybody on Zoom. Can we have a quick check of mic we'll start with Achal. Achal, आवाज आ रही है? Can you hear me quickly?
Yes, sir.
Yes, great. Vasu, how about you? Can you hear me quickly? Clearly?
Yes, sir.
Okay. Praveen, good evening. How are you, Praveen, now? Hello, Praveen? Hello, Praveen? Okay, cool. So let's start with the session for the day, everybody. है ना? तो ये दूसरा session है. It's the second part of the same session that we had started originally. We're going to work on right now moment of inertia का other cases. अभी first part में we had taken moment of inertia. I'll just make you all revise whatever we did. है ना? So 1 minute. So as you all can see, this is what was our thing that we were doing some time back. Yeah. So have a look. This is what we were doing some time back. We had started off with the concept of rotation. We solved a lot of questions understanding how to calculate the value, how to calculate omega, how to work on alpha, calculate the number of rotations, right? Concept of moment of inertia. We got introduced to this new concept. We understood that moment of inertia for any point mass, किसी एक point mass के लिए the moment of inertia का value is equal to mr square. Then we moved further ahead. We solved a lot of questions, SI unit, the concept of how to get the dimension of moment of inertia. Then we saw that there are two major types of moment of inertia values or the bodies that we'll come across. One are continuous systems, other are discrete systems. We saw questions based on both of them. Now let us take one more question. We started with moment of inertia for continuous bodies. We saw how there was a rod. हमने एक rod देखा, right? This rod was of mass m and length l. We know that for any point mass, moment of inertia is product of m and r square. Then we considered a small element of it dm, जिसका the length of which is dx, and it is at a distance of x from the axis. After which we calculated the value of moment of inertia, which is di is equal to dm into r square, or in this case dm into x square. Now, as we just discussed, that there are two different types of cases possible, right? One are cases where bodies are uniform in nature. The bodies are uniform. In second case, the bodies are non-uniform. So when we are talking about a rod, so here if the mass distribution is uniform, then you will say that mass per unit length or linear mass density is constant. In the non-uniform case, linear mass density is variable, right? Acha, everybody, are we clear until this point? A quick raise of hands, dear learners, if until this point you all are very clear. So Aryan, Achal, yes, Vasu, everybody. So I think Praveen has joined this session only. He was not there in the previous session. So you can definitely answer in the coming classes. It's very okay, Praveen. Meanwhile, others, are you all clear with this? I hope you all are, right? Okay. Then we understood the concept of linear mass density, solved a question where there was a uniform rod. Now I'll give you all a question where the rod is not uniform, and let's try to solve that one. Okay? So what we derived moment of inertia of one rod about one of the ends. Uska moment of inertia came as ml square by 3. Now let's work on other questions. So this is your next question, and you will also take this in the form of a specific case. Okay? You can take this as a case also or question also. You can give the heading if you want. Yeah, you can give the heading non-uniform rod moment of inertia. You all can give the heading moment of inertia for a non-uniform rod. Non-uniform rod. Non-uniform rod. And then write moment of inertia. We are calculating moment of inertia for a non-uniform rod. Right, so let's start. Let's begin. So here is the question. So everybody get ready. I'll write down the options here. Okay? Try to solve this one. So the question is, you are again given a rod like this. Let's make the rod over here. Okay? This is the axis. I will make the rod. So this is the rod. Okay. Question says that, should we make it better like this? Sure. This is the rod. Rod ka one of the ends is placed at the axis like this, in the just like the previous case, but there is one difference this time. In the question they tell you that the mass, they, rather than telling you the mass of the rod, they tell you that the distribution of mass is like this. They give you the value for linear mass density. I repeat, they have given you in the question value for linear mass density. You all will write this into your copies, dear learners. Right here it is given that for this rod of length L, it starts from 0, 0, 0, and extends till the point L, 0. They have given you linear mass density. Linear mass density, Aanchal, what is the SI unit of linear mass density once again?
For linear mass density is mass per unit length, so it will be given as
kg per meter.
kg per meter, yeah.
Good. So now everybody have a look. Linear mass density ka value is given to you all as AX plus BX square. Write this everybody into your copies. AX plus BX square. Okay. Now they say that you need to calculate. Okay. We can have different kind of questions. Okay? I can ask you to calculate the total mass. This is one type of question. Let us try to do it. I'm asking you calculate total mass of this rod. Calculate total mass of this rod. Total mass. Aryan, ये अपन कर पाएंगे क्या? Will we be able to solve this? What do you think? Total mass निकाल पाएंगे? कैसे निकलेगा? Tell us formula. Yes, what's the value of lambda? Linear mass density कैसे लिखते हैं आर्यन? dm by dx or dm into dx?
dm by dx.
dm by dx. तो अभी dm by dx का value और lambda is given to you. Can you calculate m? आर्यन कैसे होगा? चलो देखते हैं. Let us have a look. I'll give you all the options and give you the hint. You all will have to calculate और फिर we'll discuss. ठीक है? चलो. So everybody, here is your set of options on the screen. है ना? अभी देखना everybody ध्यान से, बहुत प्यारे ढंग से. ठीक है? An excellent question. So gamers is saying hello gamers, welcome to the session. यहाँ देखना everybody, we are given what is the value for gamma. Come again, Aryan. What's the value for gamma in the question?
AX plus BX square.
BX square. And we know that this is mass per unit length. So we can also write it as dm by dx. Right? Where what is dm? What is dx? Abhi, if this is the rod, suppose this is the rod here, and here is the axis passing through the rod's end. Passes through the end of the rod. I'll draw it once again. Just a second. Okay, suppose the axis is passing from here, है ना? Axis का value. So Piyush is saying a hello. Hello Piyush, welcome to the session. Right, तो अभी axis is passing from here. अपन लोग क्या करते हैं? Aryan, do you recall? We take a small element यहाँ पर जिसका length is dx and जिसका mass is dm. Correct? The distance of this elemental mass from the axis is x. अब क्या करते हैं आर्यन? I want to calculate the total mass. हाँ आर्यन बोलो, what do we do? इसके बाद कैसे निकालें? अभी हम क्या लिखते हैं? Linear mass density is equal to dm by dx and then we equate it to dax plus bx square. I want to calculate total mass. Total mass क्या होगा आर्यन? What will be total mass? m total, or the sum of all such elemental masses will be integration of dm. Correct आर्यन? Have a look.
Yes sir.
Right? अभी can you calculate dm from this? इससे निकाल सकते हैं क्या? Can you calculate dm from this expression? Tell me what will be dm.
Yes sir.
चलो
dx into ax plus bx square.
ax plus bx square times of क्या? dx will give you the value for dm. अभी limits क्या है आर्यन? What are the limits for x in the given question? 0, 0 से until what time? हाँ.
Yes. 0, 0 to L.
Very good.
0.
Yes, chalo. So study only saying, please reply, sir. Hello, study only. Hello. Piyush Yadav is saying hello sir. Hello Piyush Yadav, welcome to the session. Okay, चलो great. अभी यहाँ से we all will integrate and calculate the values. So get ready. How many of you can do it? जल्दी से. Can I have a quick raise of hands, dear learners? I'll give you all the poll. ठीक है? All our YouTube viewers as well as the Zoom students over here, Zoom subscribers. जल्दी से. Can we calculate this? जल्दी से. If we can, raise your hands. कितने लोग कर सकते हैं? So Makesh, Achal, Aryan, yes, Praveen, Vasu, जल्दी से. How many of you say sir हम कर सकते हैं? Okay, जल्दी से. Quickly raise your hands. Praveen, can you do the integration? Praveen, yes. Do you want the hint? Okay, here is the hint. Praveen, integration of x power n dx is equal to x power n plus 1 by n plus 1. Come on, you can do it, Praveen. Try. Come on, yes. You're very capable and strong, Praveen. Come on, go ahead. Yes, everybody, you all are very intellectually strong learners of mine. You all learn very fast. Sab kar sakte ho. You all can do it. Come on. Yes. चलो डन एवरीबडी डन स्टार्ट इट चलो जल्दी से यस टेक अ स्क्रीनशॉट इफ यू वांट आई जस्ट राइट डाउन द ऑप्शंस हियर ऑन द स्क्रीन ठीक है ऑप्शंस लिख देते हैं यू ऑल कैन स्टार्ट विथ योर वर्क तो आई राइट डाउन द ऑप्शंस बहुत सिंपल होगा क्वेश्चन ठीक है सो ऑप्शंस आर AL स्क्वायर बाई 2 प्लस BL क्यूब बाई 3 सो अंकित कुश लेक्चर्स सेइंग हेलो सर स्टडी ओनली के पूछते हैं कि सर आप कहाँ से हैं आई एम फ्रॉम रायपुर छत्तीसगढ़ डियर लर्नर्स मैं कहाँ से हूँ मैं हूँ रायपुर छत्तीसगढ़ पता है ये ना मुझसे अनअकैडमी पे भी बहुत सारे बच्चे पूछते हैं मैं कहाँ से हूँ लेकिन वहाँ पे मुझे अपनी आइडेंटिटी डिस्क्लोज करना अलाउड नहीं है या अपने लोकेशन को डिस्क्लोज करना अलाउड नहीं है तो मुझे बोलना पड़ता है कि मैं बच्चों के दिलों में रहता हूँ तो आप मेरा वो भी एक एड्रेस नोट कर सकते हो Where does Khushwant sir live? He lives in the hearts of the dear learners, है ना जो अच्छे से सीखते हैं समझते हैं है ना उन सभी लर्नर्स के दिलों में रहते हैं अपन चलो everybody I hope you all are clear with the question you are given that there is a mass there is a rod of mass is not known okay we need to calculate the mass linear mass density यानी कि mass per unit length lambda is variable आंचल how can we say something is variable आंचल कैसे बोल सकते हैं कोई चीज variable है yes आंचल
If it's given as a function of distance or time.
हाँ when something is given as a function of space and time यानी कि space coordinates के terms में या in terms of time when any variable is expressed or any quantity is expressed we say that quantity is variable इसमें it is very clear कि lambda is given as ax plus bx square मतलब there is dependence of linear mass density on x इसीलिए it is a variable quantity now we are being told calculate the total mass of the substance and lambda is given तो हमने क्या किया lambda is dm by dx फटाफट से integrate करना है we need to get to the final answer so you all know the steps you all know the formula Praveen now can you do it Praveen dear yes properly easily chalo very good very proud of you Praveen chalo let's start this everyone I will start the poll is starting here on the screen as well as on the YouTube get ready all right go ahead everybody come on so poll is starting on YouTube also dear learners go ahead and tick your answers so all right yes poll has come over to you dear learners come on yes jaldi se waiting for you all done everyone chalo come on I'm waiting for you all 24 seconds are done 25 27 kitna time चाहिए 45 seconds okay take 15 more seconds and then we'll go ahead jaldi se come on yes कर सकते हो तुम सभी लोग you all can do it all right so Ankit is asking hello sir क्या आप UP board का भी चलता है sir no I generally take lectures for JEE and NEET particularly dear learners all right time is over 5 4 3 2 and 1 I'm closing the poll all right I'll share the results क्या बात है so I'll close the poll on YouTube as well चलो great अभी let's discuss the solution बहुत simple था question everybody have a look here on the question अभी we were just asked कि हमें total mass बताना है आर्यन can you explain कैसे करेंगे yes आर्यन over to you हाँ बोलते जाओ explain everybody
Sir, integration part.
हाँ integration part yes
Sir, integration ax dx plus integration bx square into dx.
dx that will become how much हाँ
Sir, a will come out as its constant x square by 2 plus b x cube by 3.
very good super अच्छा what is the limit for x in this question आर्यन
0 to l.
L, 0 to L. So have we calculated moment of inertia or we have calculated total mass? What have we calculated, Aryan?
Sir, total mass.
Total mass we have calculated. Okay, so let us write that here, everybody, on the screen. How many of you are clear? Simple Dana approach. Whenever you are given with linear mass density, now it's easy for you all to calculate the mass. How many of you are clear? Jaldi say, kindly bring your hands down. Ronit, you can raise your hands because your hand is already down. Dear learners, come on, let me know. Okay, great, super. Done, 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 everybody. Alright, so here there is a student by study only. Name. He says, sir, I'm the grandson of Bhupesh Baghel, the CM of Chhattisgarh. Oh, ho, ho, ho. Good, good, good. If you claim that, good to hear that. Okay. Chalo, everybody, are we all ready for the next one? How many of you are clear? Aanchal, Aryan, okay, everybody, लिख लो. Write this down into your copies. जैसे ही हो जाता है, फिर आगे बढ़ते हैं. Everybody, ठीक है? Let's take a screenshot. ले लो, screenshot ले लो. This is the question. है ना? Take a screenshot if you want. 5, 4, 3, 2, 1. All right. Now the next one. Vasu, are you clear with the concept? Vasu ji, yes. Correct answer is option number A or option number B? Vasu. Option number A. Okay, chalo. Take a screenshot, everyone. 5, 4, 3, 2, 1. All right. Chalo. Let's go ahead. ठीक है? आगे बढ़ते हैं. Let's move ahead to the next question. अभी we all are clear कि कैसे we calculated the mass. Suppose I ask you now to calculate the moment of inertia. आंचल, ये क्वेश्चन अटेम्प्ट करना चाहोगे? विल यू लाइक टू अटेम्प्ट दिस क्वेश्चन? आंचल, कैसे करना चलेंगे? चलो बताते जाओ. अभी व्हाट इज द मेजर फंडा? अभी व्हाट इज द ओनली डिफरेंस दैट विल कम इस क्वेश्चन और प्रीवियस क्वेश्चन में? आंचल, वी आर गिवन विद द मास वैल्यू यहाँ पे ऑफ द टोटल रॉड कैपिटल M एंड से लेंथ L. वी कैलकुलेटेड कैपिटल M एज कितना आया आंचल? If lambda is ax plus bx square, what is the value for mass that we just calculated? हाँ, आंचल.
Equal to x square plus b by 3x.
bl square by 2 plus bl cube by 3, है ना?
Yes, sir.
चलो, we calculated the value for mass. Now I ask you calculate the value for moment of inertia for this rod about this axis. अगर rotation takes place about this axis, calculate the value for moment of inertia for this rod. सबसे पहले तो मुझे बताओ आंचल, is this case of uniform distribution of mass या फिर non-uniform distribution of mass?
Uniform distribution of mass.
पक्का यूनिफॉर्म कि नॉन यूनिफॉर्म?
Sorry, non-uniform है.
Non-uniform distribution of mass. Non-uniform distribution of mass. Okay. So now Achal, next step is अभी I ask you to calculate the moment of inertia. Formula क्या होता है for non-uniform या variable distribution? हाँ Achal, what's the formula? I is equal to, हम लोग एक छोटे से पार्ट के लिए निकाल लेते हैं. Correct आर्यन? Achal, we calculated for a small part. Suppose this part has a mass of dm and length has dx. Its distance from the axis is x. For the small mass, I can calculate the moment of inertia. अभी for a point mass क्या होता है? If there is an axis और उससे point mass है, point mass के लिए what is the moment of inertia? आंचल, mr square है ना? m into r square. Similarly, अभी इस छोटे से elemental mass के लिए di क्या हो जाएगा? आंचल,
Integration of
no, सिर्फ di.
yeah,
dm into r square, correct? अभी पूरी रॉड के लिए what should be moment of inertia? Here r के जगह x आ जाएगा. So we'll write di is equal to x square into dm. अब क्या करें? नेक्स्ट आंसर.
Integrating on both sides.
हाँ, अभी we need to calculate total moment of inertia. तो अभी कर दिया हमने integration on both sides. बहुत ही बढ़िया, चंगा सी. चलो, अभी we have this as इंटीग्रेशन डी आई. अभी वी हैव इंटीग्रेशन डी आई के बाद यहाँ पर एक्स स्क्वायर डी एम. क्या हम डी एम लिख सकते हैं आंचल फ्रॉम व्हाट वी हैव जस्ट लर्न? लैम्डा कैसा दिया हुआ है? लैम्डा इज गिवन एज ए एक्स प्लस बी एक्स स्क्वायर, है ना? और इसी लैम्डा को वी कॉल एज मास पर यूनिट लेंथ और डी एम बाई डी एक्स. तो क्या यहाँ से वी कैन राइट द वैल्यू फॉर डी एम? आंचल, निकाल सकते हैं यहाँ से डी एम? कैन वी कैलकुलेट इट?
Yes, sir. dm will be equal to bx into ax plus bx square.
Good. Let's write that, everybody. So x square into ax plus bx square times of dx. शानदार, very good. अभी we have the value for integration. अभी क्या limits of x is known to us, आंचल? यहाँ पे for this rod, do we know how does x vary? I'll once again get it to the front part. हाँ, अभी suppose this rod is placed along the, suppose this rod is placed, just 1 minute. 1 minute. Okay. So I will take pointer here. Okay, suppose this part Suppose this part is the one that we are talking about. तो मुझे आंचल एक बात बताओ, for this particular part क्या हम ये बता सकते हैं यहाँ से क्वेश्चन से देख के कि what is the range for x? ये start हो रहा है at the origin, it is starting from origin 0,0. Can you calculate what will be the end point of this rod at what will be the coordinates of the end point of the rod? Yes, Anshul, it will be L,0, correct?
Yes, sir.
है ना? क्यों? Why L,0? Because in the question they are
Length
that
is given.
length of the rod is given. By that logic हमें समझ में आ रहा है, we are very clearly able to understand कि इस rod के लिए x का value will range from 0 to L. चलो, let's write that over to you everybody. Let's go ahead and substitute the limits. So it will be 0 to L. कितने लोग कहते हैं? How many of you say sir try करते हैं? Give us the poll. We'll go ahead for integration. Raise your hands quickly. How many of you are ready for the integration? Here are your options coming up on the screen. Jaldi se, quick. Jaldi se. So Praveen says, sir, I'm ready for the challenge. So does Makesh, Aanchal, Aryan. Okay. Ronit says, sir, aap kar dijiye. Vasu Ajay says, sir, aap kar dijiye. We are not ready for the challenge. Kyun? Karo. Try this out, everybody. Come on, jaldi se. I'll write down the options here on the screen. Go ahead, everyone. So first one is AL cube by 3 whole plus BL power 5 by 5 or AL power 4 by 4 plus BL power 5 by 5 AL cube by 3 plus BL power 4 by 4 है ना? And next one is none of these. Chalo, we'll start with the poll, dear learners, on YouTube as well as for all our Zoom learners. Come on, get ready. शुरू करते हैं poll. Here's the poll starting on the screen. And yes, go ahead. Yes, come on. जल्दी से try this out. So poll launch किया जा चुका है. The poll has started for our learners here on Zoom. You all will have 1 minute to crack this one, so don't take any more time longer. It is a simple question. I've already solved it for you all. You all just need to do the integration part and tell me, sir, this is the answer. Okay, 21 seconds are already over. How about the remaining time that we have in hand? Chalo, jaldi se, quickly, try this out. 30 seconds gone. Come on. 30 more seconds to go. Everybody. Yes, dear learners, let me know. Done. So we have to go from x is equal to 0 to L. Let's see, time 4 more seconds. 3, 2, 1. Closing the poll now. ठीक है. Alright, I'll share the results with all of you. 100% of those answering have answered it correctly. Very good. Chalo, can I have a quick raise of hands from everybody who could answer it? Jaldi se, raise of hands from everybody who could answer it. Aryan could answer it, so could Makesh. And then, who else could answer it? Aanchal, very good. Okay, so one more could write. 4 of you could answer it correctly. Aryan, okay. Praveen, any issues with this simple question? Yes, let's discuss it with you. Praveen, ready? Praveen ji, ready?
Yes, sir.
Chalo, tell me what will happen. Let us multiply x square into yes,
ax plus bx square.
Okay, chalo. So this will be ax cube, correct? Plus
Yes, sir.
bx power 4. And then let's integrate it. So when you do a combined integration, what will you get, Aryan?
We need to separate it, sir, and then
Let's separate it and then integrate. What will your integration come as?
yes, sir, x cube, x power 4 by 4
by 4 plus
b into x power 5 by
5 by 5. Very good. See, easy tha na, Praveen? It was easy, right? Chalo,
Yes, sir.
and you'll take the limits. What will be the limits and final answer equal to AL power 4 by 4 plus of BL power 5 by 5. Kya baat hai, super. So Yogesh says, sir, Maharashtra Makesh, Aryan, if you are clear, quickly raise your hands. Chalo, if yes, let's write this down and then let's solve more questions. So हमने क्या देखा? What I'm trying to basically let you all understand is कि whenever in the question they are asking you कि कैसे, how to calculate the value for moment of inertia of a rod of constant linear mass density. We just saw that as the previous question, and in this question we saw what if the linear mass density is variable या non-uniform. One more word for non-uniform is also variable. I repeat, वेरिएबल को ही नॉन यूनिफॉर्म या नॉन यूनिफॉर्म को ही वेरिएबल भी कहते हैं, राइट? we'll solve more questions, you all will get used to it. So very simple, कोई tension वाली बात नहीं है. Quickly take a screenshot of this part or start writing it, complete your lecture notes and then put a hand down. Over to you dear learners. Yes, come on. Jaldi se, once you all are done, put your hands down. So Praveen has done this part which is there on the screen. Yes, Aryan has completed. Okay, great. Aanchal is writing, Vasu is writing, Ronit is completing his work, so is Makesh. Once you all are done, let me know with the hands coming down. Dear learners, okay. So Aanchal has completed her work, so has Aryan, Ronit, Praveen, Vasu and Makesh are writing it. Should we go to the next question, next part of the question? Take a screenshot if you want. 5, 4, 3, 2, 1. All right, here is the next part of the same question. Go ahead and put it down in your copies too. Dear learners, go ahead. Yes, and bring your hands in the raised position once you all are done. I put all hands down. Yes, jaldi se. Take a screenshot if you have less time and a lot to write. You can complete it later also. 5, 4, 3, 2, and and 1. Done. Chalo. Okay. Cool. Alright, dear learners, let's go ahead. है ना? So अभी ना similar questions can be there. अभी इसमें what was the option number? Praveen, which option is correct? Option number B. Yes?
Yes, sir.
Okay, great, superb. So finally, let's move to the next question now. Next question पे आ जाते हैं. अभी ना you can have a lot of these kind of questions that you can solve and you can understand how to solve the moment of inertia based questions. We all can keep solving it until time infinity. So I'll try to take some questions है ना, and then we'll go ahead with further work. तो अभी कुछ questions अपन यहाँ ले रहे हैं अभी, और बाकी के आप लोगों को I'll tell where you need to study from. Let's take a ring. So give the heading moment of inertia for a ring. Give the heading everybody. Moment of inertia for a ring. Yes, moment of inertia for a ring. Inertia for a ring. ठीक है? Yes. चलो, let's solve this one. तो अभी ring में where are we taking the axis? We will take the axis at the center. Let's take the axis at the center of the ring like this. Sometimes no, these kind of axes are also called as geometrical axis. कई बार कई सारे किताबों में in many books you will find the word geometric axis of a ring. तो geometric axis मतलब the axis which generally passes symmetrically through that system as well as passes through the center of mass. कभी कभी question में they use the word geometric axis. ये geometric axis क्या होता है? Geometric axis is that axis which passes through the center of mass of that system as well as it is dividing that system symmetrically. Symmetric parts है, system is symmetric about that axis. Such axes are generally called as geometric axis. ठीक है? But generally in this case, this is the geometric axis. In further cases, I'll let you know कैसे identify करना. चलो, quickly, everybody, let's move ahead, है ना? तो let's solve this one with, who will solve this with me? So can we take Makesh? Ready? Let's solve this with you. Ready?
Yes, sir.
चलो अभी क्या करेंगे? What did we do? Is it a continuous system या is it a discrete system?
Continuous system. Sir.
For a continuous system, what is the formula, Makesh?
Sir, integral mi ri square, sir.
Tell me once again. Integration of
di.
And di can be written as x into r square into dm. Correct?
Yes, sir.
Okay, now let us take a small part, a small element of this system, you know, and this small element is at a distance of how much? Radius r. Let's take the radius is r for this ring. Let's take its mass is m. I repeat, for this ring we are taking mass is m and radius is r, and we want to calculate the value for moment of inertia. Now, by the logic, tell me one thing. In the previous question, Makesh, let's try to understand the difference in this and the rod case. Makesh, when I take different points on this rod, when I take different elements of this rod, say this is the first one, then I take a second one here, third one here, fourth one here, fifth one here, sixth one here. For all the elements, is the distance from the axis same or different?
Different, sir.
So here the difference is, everybody, you all can take this as a note also if you all like, कि यहाँ पर rod के case में the distance of the element masses which we were taking was different for each mass. I repeat, distance of distance of each element is different. Each element is different. I write this, huh? This is a very important note. आपको समझ में आना चाहिए what you are actually doing here. So distance of each element is different distance of each element from the axis of rotation. From the axis of rotation, यानी कि axis of rotation से हर एक element का distance अलग अलग है. The element is different, the distance is different for each element of the rod. But the same is the same also true here? Makesh, what do you think? You think that all the points of this ring, are they at the same distance r, or are they at different distances from the axis at the center? What do you think, Makesh?
Sir, same distance.
Absolutely correct. अभी for a ring बोलते ही तो उसको है. What is a circular body? A circular body is a body which has all the particles distributed in such a way कि हर particle का, for every particle the distance from the center is same. It is not different. So whether you take this part, this element or this, या ये, every element will be at the same distance which is equal to the radius of that ring from the axis. I repeat, you all can write this down into your copies if you like, that here in this case, the distance of each element is same from the central axis of rotation. In this case, distance and equal to r. Distance of each element is same. Distance of each element is same. Distance of each element is same from the axis of rotation. From the axis of rotation. And is equal to r. The distance is same and is equal to r. And is equal to r. How many of you could get this idea? Jaldi se bring your hands in the raised position, down position. Yes, bring your hands down if you could understand this idea, this logic, that in case of rod, every element was at different distance from the axis. जबकि यहाँ पे every element is at the same distance r from the central axis. If you could get this notion, this idea registered into your mind, please bring your hands down. Aryan and Vasu want to ask something. Let's take their questions. Yes, Aryan ji boliye. Okay, he's clear. Vasu ji, yes, please let me know. Clear? Vasu?
Yes, sir.
Okay, great, super. So, Abhi, let's come back to Makesh. Makesh, tell me, so instead of this r, what can I substitute here? Capital R square or radius of the ring?
Yes, sir.
Right? And dm. So, let's take this d. So, what about the constants? Do they go outside the integration or do they remain inside, Makesh?
Outside, sir.
Outside. So, let's take it outside. R square integration dm. So, integration dm means total mass or only mass of one element?
Sir, mass of that element, sir.
No.
Total mass, sir.
Integration. What does integrate means? To bring together. So
Yes, yes.
This is dm. This is also dm. This is also dm. This is dm. This is dm. All of them are dm masses, and we are integrating. Integrating means summing them up. So when you will sum up all the elemental masses, what will be the total mass equal to, Makesh?
Sir, m, sir.
M. Let's write it m. Good. So this is integration dm means the total mass or the sum of all these small elemental masses. This also means integration means sum of all small elemental masses. Elemental masses. जब तुम सारे elemental masses को add कर दोगे, that is what integration is. You will get the total mass and you will have the answer as mr square. So Praveen, what is the moment of inertia for a ring? Praveen, yes. What is the moment of inertia for a ring, Praveen? mr square. And should it be same for all the axes, or will it be different for different axes? What do you think?
It will be same, sir.
No. If I suppose I take the axis here. Tell me, will now every point will be at the same distance from the axis? Or now will every point will be at the different distance from the axis?
It will be different, sir.
Will be different. So the value of moment of inertia when you will take it about an axis which is say parallel at some other location will be different than the value for moment of inertia when you will consider the axis passing through the center. So please mark moment of inertia about different axis is different, not same. Meanwhile, you all can write this down into your copies. Mr square is the value for moment of inertia which we just derived for the ring, in the same way, just the way we derived the value for moment of inertia for the rods, uniform and non-uniform cases. Jaldi se copy mein likh lo everybody, and then we will go to the next question. So everybody there on YouTube, aap bhi keh sakte ho, sir, we are done writing, and then we'll take more questions. Okay? Keep your copies ready and keep going. So once you are done, raise your hands. I will wait for you all. Anchal, Makesh, Praveen, Ronit, Vasu, everybody watching this session over here, the Zoom subscribers, once you all are done, let me know and then we'll go ahead. Chalo, come on, quickly. Waiting for you all, everybody. Come on, come on, come on. Go ahead. Likh lo, likh lo, likh lo. Write this down into a copy. So Ron has completed. All right. Okay, I think Makesh has completed. Anchal and Praveen, Ronit has also done. Vasu is yet writing. We'll take a screenshot, Vasu, and then we'll go to the next question. 5, 4, 3, 2, 1. All right. Before we move ahead, Vasu, have you submitted your assignment already? All the assignments that I've given. How many of you have submitted, Vasu? Hello, Vasu, are you there? In many sessions, Vasu escapes also. Vasu, are you there? Hello? Hello, Vasu? Should I remove you from this session, Vasu? He's not there, huh? Are you there, Vasuji? Hello, hello, hello. Sir, I'll pretend that I'm not there. Hello, Vasu, are you there? Chalo, theek. I'll assume that you're not there. Chalo, everybody quickly go ahead and write this down into copies. Right? Take a screenshot, Vasu. 5, 4, 3, 2, 1. All right. Take a screenshot. Vasu, are you there? Hello. Respond, Vasu.
Yes, sir, I'm there.
You're there. Okay. Sometimes you leave, no? In the evening session, you go away, right?
Sir, I did go away in the last session, like I was eating, so.
Okay. But you should message, right, Vasu? Shouldn't you?
Sir, I should, but I thought it will be done fast, but then it got delayed. Sorry.
I was calling you for a very long time. Where is this boy gone? Cover the
Sorry.
sessions. Wherever you miss out, Vasu, do cover the sessions, okay? Yes, take a screenshot, Vasu. Yes, and do cover the sessions. If you're leaving a session for some reason, please cover it, okay, Vasu? Chalo. Now, write this down, everybody. How many assignments have you submitted, Vasu?
Sir, I didn't submit.
Not even one yet?
I did one, like I just
Okay, okay, chalo. I'm waiting for the submissions, Vasu. Be
Yes.
quick. Give me a date. Send me a date when you will be submitting. When will you be submitting? At least one assignment, Vasu.
Sir, I'll submit it day after tomorrow on Monday.
Okay, good, good. Chalo, good. Now take a screenshot, everyone. 5, 4, 3, 2, 1. Chalo, let's go ahead. है ना? आगे बढ़ते हैं, everyone. ठीक है. So let's take one more question. Let's take it for a disk. Let's talk about a disk. So in case of a disk, Abhi, what is a disk? Disk is nothing but several rings placed one by one. I repeat, एक disk क्या है? What does a disk mean? So a disk is nothing but several rings which are placed side by side like this. Try to visualize this. How can you form a disk? You can form a disk if you're taking several rings side by side. If you take several rings side by side. So we are taking the example of, right now I want to calculate moment of inertia for a disk. So I'm assuming that a disk is made up of several rings like this. Everybody have a look. Moment of inertia for a disk needs to be calculated. So the basic assumption or the basic visualization that we all need to do कि एक डिस्क कई सारी रिंग से मिलकर बनी है. A disk is made up of several rings together, several rings placed like this. Yes, everybody. So you all can continue this pattern. ठीक है? This pattern will keep on continuing inside one also like this. ठीक है? And so on and so forth. ठीक है? You all can put this into your copies and give the heading for a disk. Moment of inertia for a disk. Yes, chalo. Everybody go ahead and write this down and then we'll move further. 1 minute. Okay. Done, everyone? Each one of you? Okay. Chalo. There's something with my screen right now. Just a second. Now it's cool. Chalo. Heading likhna, everybody. Write the heading. Moment of inertia for a... Moment of inertia for... Okay, so... 1 minute. Write the heading, everyone. Moment of inertia for a disk. Okay, chalo, write this one. So abhi kya ho raha hai? We are taking different disks. So the first one, hai na? Suppose this is the first disk. This one, suppose, has a radius of, let us say, r, small r. Okay. Then next disk might be having a radius, suppose the thickness of any one disk, let us take, okay? Let us take a disk here which has a thickness of dr or dx, and then from the center it has a distance x like this. I repeat, I will write it here. Isko aise karte hain. I will write it here. Aisa dekhna everybody. Suppose I have this disk, iska thickness, or this ring ka thickness, let us take dx, and this ring is at a distance of x from the center. Okay, x from the center, and meanwhile I'll rub this one. Okay, chalo. Everybody write this into your copies quickly. Once you all are done, let me know. Okay, yeah. So you can take this as a question also, or as a derivation also. Dono chalega. Anything would do. Bring your hands down. Can you all bring your hands down? Yes, I'll ask you to raise your hands very shortly. Chalo, everybody. Done. Moment of inertia for a disk we want to calculate. Okay. So, abhi we'll take this with Aryan. Aryan, can you tell us, for a disk, mass is distributed along length or mass is distributed along area? Hello, Aryan, are you there? Achal, is my voice clearly audible to you?
Yes, sir.
Okay, yeah, let's take this with you. So for a disk, Achal, sir, हम लोग क्या लिखते हैं? The mass should be distributed along the area, या the mass should be distributed along the length? क्या लगता है, Achal?
Along the area.
Along the area. तो we'll write surfacial या aerial mass density. We'll write surfacial या aerial mass density. Mass density. ठीक है? And it should be equal to dm by dA या dm by dl?
dm by dA.
dm by dA. Write this, everybody. This is nothing but mass per unit area. Yes, everybody will write mass per unit area. Over to you, dear learners. Quickly put this down into your notes. So abhi, Achal, suppose the radius of this disk is equal to, total radius of this disk is suppose equal to r. What will be the total area for the disk, Achal?
Pi r square.
Pi r square. So in this case also we can have two cases. One can be uniform and another one can be non-uniform. So you can have two types of questions of this regard. You can have disk of uniform area, disk of non-uniform area. So suppose you have disk of uniform mass distribution. Abhi, this is what is asked in the previous year's JEEs. I'll give you all questions you'll understand. So suppose uniform and non-uniform, okay? Uniform. So in case of uniform, tell me what will we write? Sigma or mass per unit length as simply, suppose total mass is m. So what can we write? Mass upon area A, correct? Which will be given as mass by pi r square or 2 pi r square?
Pi r square.
Pi r square, very good. So let's write that, mass by pi r square. Non-uniform ke case mein what will we be writing, Achal? Here, let us take this. Good. Everybody write this down. We can have different kind of variations. Yahan pe I'm giving you all example. Here, this is a function of r. This is a function of r. For example, sigma can be written as some k times of r, suppose where k is any constant, okay? K times of r, or sigma can be this into 1 by r, or it can be sigma is equal to k naught into r square, etc., or it can also be sigma is equal to a plus br. Different kind of ways sigma can depend upon the radius. Yeah, distance from the center. If sigma is variable या the linear mass density is varying with the radius, तो हम बोलेंगे that the distribution is non-uniform. And if the sigma value is not varying with radius, yeah, it is same all along, then we will say that it is a uniform mass density. ठीक है, everybody quickly put this down. जैसे this part is done, we'll go to the next one. Raise your hands once you all are done writing. Dear learners, go ahead kindly. Yes, chalo, फटाफट. Once you all are done, we'll go to the next part. Yes. Waiting for you all. Quickly raise your hands once you all have completed writing. Ha. Okay, go ahead. Acha, Anshul, okay, let's take this with Vasu. Vasu, if I want to calculate the total mass, how will we calculate? Suppose I want to calculate the total mass. How will we calculate from this equation? Can you calculate it, Vasu?
Yes.
How? Total mass is integration of dm or just dm, Vasu?
Integration of dm.
Integration of dm. Very good. Everybody first finish this and then we'll discuss this with Vasu, how to calculate the value for total mass for the disk. First we'll calculate total mass and then we'll calculate inertia. Yes. Anchal has completed writing, so has Vasu. Makesh, Praveen, Ronit, quickly write this part and raise your hands. Yes, we'll go ahead. Dear learners, let me know once you all are done writing. 5, 4, 3, 2, 1. Arey, what, done so quick? Chalo, let's take the uniform wala case, okay? Let's take the uniform wala case from here. Okay. 1 minute on everybody. Just a second. So, okay, everyone. So, Abhina, let's take the uniform wala case first. Vasu, are you ready? Yes?
Yes, sir.
Sure. Over here we have uniform wala case. In this case, they are giving you that there is a disk, okay, and you need to calculate its moment of inertia about the central point, and this is suppose the disk. Okay, generally they will shade the central part whenever we are talking about disk. Okay, Vasu. Yes, so let's write this over here. This is a disk and I want to calculate the moment of inertia. So what was the inherent assumption, Vasu? What was the inherent assumption? That one disk is made up of several rings, correct? What was it?
Yes,
Repeat after me,
There
Vasu.
are several rings.
So here one inherent assumption or say the point notion of understanding is ऐसा कि several rings together make one disk. कई सारी rings मिलकर एक disk का निर्माण करती हैं, है ना? Several disks together make one ring. So you all will draw one ring over here like this, and you can write here several disks or several rings together. So what do we need to calculate? Moment of inertia for a disk. ठीक है? You will write here the assumption is several rings make one disk. Make one disk. Make one disk. Sure. Yes, everybody, let's start writing. So, abhi suppose what was the thickness that we assumed? What was the thickness of this dx? Right, Vasu? And what
Yes,
was its distance? What was its distance from the center? Equal to x, है ना?
Yes, sir.
Right? Abhi, suppose I want to calculate first the mass of the disk. Suppose I want to calculate the mass of the disk, or suppose I want to calculate the mass of the ring. How will we do it? Let's try to do it. Okay? So, abhi, can you calculate the area of this? अभी ना what I'm doing, ध्यान से देखना everybody, I'm cutting this apart. ये जो disk, ये जो ring है ना, I'm cutting it from here ऐसा. Let's cut the ring. After the ring is cut, I am stretching it ऐसा. I am stretching it. And I stretch it to वो belt बन जाता है. What are we doing here? Again, I'll repeat everybody. This is the ring, ठीक है? The ring from which the disc is made. We are cutting it open. यहाँ से इसको cut कर दिया. So this will open up like a belt. How many of you can visualize this? कितने लोग ये visualize कर पा रहे हैं? That when I will cut the ring, cut the ring and stretch it. So it will be just like a straight long wire. How many of you could get that idea? It will be just like a strap of metal. Yes, bring your hands down if this idea, this notion is clear to each one of you. So Praveen, Makesh, Ronit, everybody, clear? Okay. Now, what is the circumference of a circle if the radius is r? Vasu, what is the circumference of a circle?
2 pi r.
2 pi r. So here it will be 2 pi x because the radius is x, correct?
Yes,
And what
sir.
will be the thickness of it? Equal to dx. So what will be the area of the strip? What will be the area of the strip or the ring? Whatever.
2 pi r dx.
Very good. So strip or ring will be dA. Let us call it dA will be equal to 2 pi x into dx, correct?
Yes, sir.
Now, let's go to the next point. Suppose I ask you to calculate its mass. Suppose I ask you to calculate its mass. What will be the mass? Mass of the ring or the disc will be given as dm है ना, by dA. What was the formula? dm by dA is equal to
2 pi r x dx.
let's write this, everyone. So what was the linear mass or here areal mass density का formula? Sigma. What was the formula for sigma? अभी we need to calculate dm. What was the formula for sigma? Sigma is equal to dm by da है ना, mass per unit area, right? So
Yes.
here I can write in the next step, therefore, like 1 minute. So in the next step we can write therefore dm by da is equal to sigma, correct? Let's write it. So we can write therefore dm is equal to sigma into dA, correct? And
Yes.
what is dA? We just calculated dA as, tell me, 2 pi x
2
dx.
pi x dx.
है ना? So this is that mass of the ring. I repeat, this is the mass of the ring, and this sigma value can now be equal to total mass of the disk upon the total area in case of uniform distribution. Whenever we are talking about uniform distribution of mass or a uniform disk, this will be sigma is equal to m by a, or in several questions they can give this value, sigma as some function of r, example mr square, or any function. It can be any function. Here I'm just taking an example, or they'll give it to you as a function of r. So this is the logic, ये तरीका है by which you can solve this question. So I'm writing it r here. It can be equal to x. आप चाहो, if you all want, you can take this r, you can take this x, whatever, anything, whatever you like, you can take this. Ayush Yadav is saying a hi. Hello Ayush Yadav. I hope you're doing good. चलो everybody, कितने लोगों को clear है? How many of you are clear on this? जल्दी से can you all quickly raise your hands? This idea, this ideology, I'll repeat it for all of you shortly. ठीक है? Moment of inertia for disk is being calculated. We understood that in a disk mass is distributed aerially या surface के along. So surface mass density is equal to dm per unit area or dA, where dA is the small area of one strip and dm is the mass of that strip. Then we understood इसमें two तरह के cases can happen. One will be uniform, another will be non-uniform. Then we did a question. अभी we want to calculate the moment of inertia and mass of the disk. How did we go for it? हमने कहा let's take one of the, अभी ना हमने कहा कि this disk is made up of several rings. So we are taking one ring out of that many rings present. Let its thickness be dx and its distance from the center be x. After doing that, we calculated area, which is equal to dA. I'll put it in the center for all of you. We said that area of the string or strip, that strip, or abhi na I've written I think string, this is a strip. ठीक है? Let, if you call it a strip, you can call it a strip or you can also call it a ring, whatever you would like to. ठीक है? So we said that कि area of this strip या ring, Vasu told कि sir this was the circumference, जो circumference था ring का, whatever was the circumference, that became as the length of this strip. The thickness of this strip is dx. So area will be dx into 2 pi x. अभी this is small area for just one strip, इसीलिए अपन ने we wrote this as dA. Now we know we want to suppose calculate what will be the mass of this ring, only the ring, right, not the disk. We are talking about just the strip या वो वाला रिंग. उसके लिए मास वी कैलकुलेटेड डीएम. कैसे निकालें? सो वी नो कि सिग्मा, अभी वी जस्ट लर्न यहाँ पे ना, वी जस्ट लर्न सिग्मा or aerial mass density is dm by da. From here we can write sigma is dm by da. Therefore dm can be written as sigma into da. So this da got multiplied by sigma, and इसके two formations can happen depending upon whether the distribution is uniform or the distribution is non-uniform. How many of you are clear with this logic? Everybody, can you bring your hands down? यहाँ तक अगर हमको समझ में आ गया तो अभी the same way we calculated the mass, we can calculate the mass here also for the complete ring. यहाँ से mass भी निकाल सकते हैं. We can calculate moment of inertia also. Let's calculate calculate moment of inertia right now. First, put this part into your copies. I'll wait for all of you. Take a screenshot. Need not write everything right now. You can write it later at your home. इसी से you will be able to do the practice also. ठीक है? So we are calculating moment of inertia of a disk. Everybody, once you all are done taking a screenshot, just take a screenshot. ठीक है? समझ तुम लोगों ने लिया, right? It's okay if you're not writing it right now. It's good. It's fine. It's perfect. So put it down into your copies, and once you are done, let me know. Yes, by raising your hands. Over to you, Aanchal, Makesh, Praveen, Ronit, Vasu, and all our YouTube viewers who are watching this session right now via YouTube from different parts of the country. Yes, आप बता सकते हो, सर हमने screenshot ले लिया है. So we are done by writing it in the comment section, and my Zoom subscribers can say can do a raise hand and say, sir, we are done with the writing part or the screenshot part. Yes. So Praveen has taken a screenshot. So has Vasu. So has Makesh. Aanchal and Ronit are taking it. All right. I'll go for a reverse counter, dear learners. 5, 4, 3, 2, 1. और ये हो गया समाप्त समय. ठीक है. चलो. Let's go to the next part. Yes. अभी this part को भी everybody kindly put it into your copies. I'll come over here. है ना? Now. You all can put this into your copies. Go ahead, everybody. 5, 4, 3, 2, and 1. ठीक है? Take this part also if you want properly. 5, 4, 3, 2, 1. Now, once again. 5, 4, 3, 2, 1. चलो आर्या, so let's take this with आंचल. आंचल मुझे बताना, अगर सपोज मुझसे टोटल मास ऑफ द डिस्क पूछ लिया जाए, ठीक है, क्या पूछ लिया जाए आंचल? इफ दे आस्क मी द टोटल मास ऑफ द डिस्क, हाउ विल वी गो फॉर इट? हाउ टू कैलकुलेट इट आंचल? टोटल मास ऑफ द डिस्क, टोटल मास ऑफ द डिस्क, it will be equal to sum of masses of different rings, correct? Sum of masses of the rings, masses of the rings. तो it will be simply dm या फिर integration dm. What do you think, Aanchal? Integration dm. Yes. And what is the value for integration dm? Sigma into dA from here, correct?
Yes, sir.
Aanchal. And what is dA equal to? We just calculated dA is 2 pi x dx.
हाँ sir.
है ना? तो या तो you can write it as 2 pi x dx या 2 pi r dr, correct Aanchal? इसको या तो 2 pi x dx कहो, you can also call this 2 pi r dr depending upon what is the denotion that you have taken. In several books like H.C. Verma and all, you will find they are writing it in terms of r. So it's completely up to us how do we refer. ठीक है आंचल, यहाँ तक कर लोगे आंचल? We can do this easy है. चलो, you can either write x or you can write r as you all prefer. ठीक है. अभी this is the way of calculating mass. आंचल, what if I want to calculate the moment of inertia? मुझे पहले ring का moment of inertia बताना आंचल. So moment of inertia for the ring. What is the we just calculated? अगर mass is m and radius is r, what did we just derive some time back? For a ring, what is the moment of inertia? Ring mr square, correct?
Yes, sir.
यहाँ पे what is the mass of one ring?
Integration of sigma 2 pi r dx.
What is the mass of one ring? dm.
dm, yes sir.
ये एक mass of one ring है, right? This is the mass of one ring, dm. आप चाहो तो लिख लो, this is mass of one ring, correct आंचल?
Yes sir.
और mass into radius square करने से you get the moment of inertia of the ring. So अभी what is the mass here? dm है ना? And what is the radius? r. Right? So we'll write dm into r square is the moment of inertia of one ring. Am I correct, Aanchal?
Yes, sir.
अभी suppose I want to calculate the value for, and यहाँ पे what is the radius of the ring? यहाँ पे radius is not capital R. यहाँ पे एक ring का radius कितना था?
X.
हाँ, यहाँ पे it was equal to x. You all can take it as r also, dear learners, whatever you all prefer. ठीक है? You can take it as x, you can take it as r. Different books have different denotions. Whatever you all like, you all can do. ठीक है? I am taking it as x, so I'll continue with x only. ठीक है? So in this case, the radius of the ring that we have taken, because it is an elemental ring. कैसी ring है आंचल? It is an elemental ring, right? So for the elemental ring, we will have radius of the ring is, in our case, radius of the ring is x. If there is any confusion, I'll come back and clear it. Have a look, everybody. ध्यान से देखना. We have a disc and then we have a small ring that we have drawn. For this disc, for this ring, we have radius as x and इसका mass is dm. इसका mass is dm. Everybody, I repeat, इस ring के लिए mass is dm है ना, इसका thickness is dx, इसका area is 2 pi x dx, इसका radius is equal to x. Now let us move ahead, dear learners. Come on, Aanchal, is this clear? याद आ गया? चीजें समझ रही हैं अच्छे से? चलो everybody, now let's go ahead. इसके लिए we'll not write r, rather we'll go for writing x का square, है ना, we'll go for writing x का square ऐसा, ठीक है. So this is moment of inertia for the ring. What will be moment of inertia for the disk? Moment of inertia for the disk, it will be equal to sum of moment of inertia for all the rings. ऐसे ही होगा, right? Sum of moment of inertia for all the rings, MOIs of the rings. Correct, Aanchal? Right. अब क्या करोगे? You will write integration of di. यही है वो di that we are talking about here. एक रिंग का moment of inertia. What is di over here? हाँ, we'll write here as x square dm. Right. अभी dm का value we have calculated. Aanchal, correct?
2 pi.
Let's write it here. So dm was equal to, we have just calculated dm as sigma 2 pi x dx, sigma 2 pi x dx. ये याद है ना आंचल? sigma was equal to dm by da, है ना, and da was 2 pi x dx. da was 2 pi x dx. Correct? Praveen, are we going in the line? Praveen, are we clear on this concept? Praveen?
Yes, sir.
है ना. So here we are going like this part is dA, है ना, this part is dA. So let's substitute it here, x square times of, Praveen, let's continue with you, pi times of 2 pi x into sigma into 2 pi x times of dx. Correct, Praveen? Have a look.
Yes, sir.
Therefore this pi and pi and sigma, 2 pi and sigma will go outside. We'll have pi into 2 sigma times of x cube integration dx. Have a look. Correct, Praveen?
Yes, sir.
Right. Okay. Now let's move further ahead. Now, why has this sigma come outside? So this is the basic formula. Okay, this is the basic formula. Why have we taken sigma outside? Why? Because we are considering uniform.
It has a constant.
When we are assuming that sigma is a constant, only then it will come out. So this is the case. This is the case when sigma is a constant or uniform wala case. We are taking uniform wala case. Everyone will write this down into your copies. Uniform. ठीक है, चलो everyone. And when will sigma not come outside, Aanchal? When it is a variable, है ना, या non-uniform mass distribution. Correct, Aanchal? Clear on that logic?
Yes, so clear.
चलो ठीक है. Okay, Praveen. So assuming it is constant, है ना? Assuming it is constant, can we go ahead with the calculation, Praveen? Yeah, tell us how will we go ahead? Sigma
Sigma
into
2 pi into x power 4 by 4, sir.
x power 4 by 4. What is x? What was x? X was the mass of x was the radius of
Distance, sir.
one distance of the ring, or it was the radius of the ring that we considered. What is the value for x at the center? 0. And what is the value for x at the highest edge of the disk? Equal to capital R. So we are assuming that the disk has a radius of r. The disk has a radius of r, and the disk has a radius of r, and its mass is m. Correct?
Yes, sir.
Okay, now we are moving further ahead. Let us take the limits. Therefore, what will be the limits, Praveen? Limits
from 0 to capital R, sir.
Capital R. Very good. So we have different rings, and for each ring we are adding the moment of inertia. It's a very simple concept. There are different rings, और सभी ring के लिए हम moment of inertia को add कर रहे हैं. We are adding up the moment of inertia for each of the ring, so as to get the idea, to get the answer. As अभी this pi, this 2 and 2 will be cancelled here, 4 will be cancelled here, to get us sigma into pi by 2 times of r power 4. Am I correct? Have a look. Minus 0 power 4. Aryan, have a look. Tell me. Hello. Sorry, Aryan, I'm saying. Praveen, are we clear until this point?
Yes, sir.
Abhi this is the value for moment of inertia for a disk. But generally this is not the value that we all know. We know a very different kind of expression. Let's get to that expression. कैसे निकलेगा? Praveen, can you express sigma in terms of mass and area? What is sigma? Mass per unit area? Yes. Abhi suppose when we are taking sigma is constant, when sigma is constant, I can write this as total mass by total area. Am I correct, Praveen?
Yes, sir.
Okay, let's substitute it then. So for the disk, we are writing moment of inertia is sigma pi by 2 into r power 4. Sigma is mass per unit area. So mass per unit area into pi by 2 into r power 4. What is the area for a disk, Praveen?
2 pi r
No,
square.
pi r square.
Oh, pi r
Pi
square.
r square. What is the area, Praveen?
Pi r square, sir.
Let's substitute. So here we'll write pi r square into pi by 2 here and then r power 4. Abhi, what will be the cancellations, Praveen? Tell all of us.
R square and pi, sir.
Pi will be cancelled, r square, and this will become r2, है ना? Or r का square. This will be mr square
MR square.
into or divided by 2. So we'll have mr square into half is the moment of inertia for the disk. Correct, Praveen? Easy and clear. है ना? We all will revise it, so no need not worry anybody, right? Very simple concept. हमने यहाँ जो भी derive किया, we'll quickly revise it and see how did we come to the final answer. Alright, but before doing that, suppose if, let's take the second question, suppose if the moment of inertia for the disk was variable, then the steps would have changed from this point. Achal, am I saying it correctly? At this point, sigma को हमने बाहर निकाल लिया. We took sigma outside, and this was only at the assumption that sigma is a constant or is equal to mass upon area for the disk. Right? अगर ऐसा नहीं होता, suppose if sigma was variable, then entire context would have changed. Am I correct, Achal?
Yes, sir.
Let's do that. Makesh, are you ready for the question? This one you all are done. You all can take a screenshot. I'll go from the first front page. Yes, go ahead and take a screenshot. Anybody who would like to. So 5, 4, 3, 2, and 1. I hope you all are done. Take a screenshot. Yes, I'm going to the next part. If anybody wants to write it, yes, please write this down. Take a screenshot. Sorry. 5, 4, 3, 2, 1. Okay, this part also. Yes, 5, 4, 3, 2, 1. You will not find things so properly written the way I am writing in most of the books. उन्होंने काफी shortcut में फटाफट they go ahead and giving you every step in detail so that you all can reproduce it later. समझ सको कि कैसे इस तरह के questions को करना है. Yes, take a screenshot everyone. 5, 4, 3, 2, 1. Right? If you want to take it again, you all can go for it. 5, 4, 3, 2, 1. Okay, take a screenshot once again. Keep a screenshot with you even if you're writing it. 5, 4, 3, 2, 1. Everyone, going to the next part. Take a screenshot. 5, 4, 3, 2, 1. Take a screenshot once again. Yes. 5, 4, 3, 2, 1. तो ये किसके लिए था आंचल? Was it for a uniform disk या non-uniform disk, आंचल?
For a uniform disk.
For a uniform disk. Very good. And this uniform disk has a mass of how much? M and a radius of equal to R. Correct, Anchal? Yes. And this is a uniform disk. And where is the axis passing? The axis is passing through the geometric or the center of mass and perpendicular to the plane of the disk. So this is a uniform disk with axis passing through center of mass and perpendicular to the plane of the disk, passing through center of mass, and perpendicular. See, the disk is perpendicular to the plane of disk. How many of you could interpret this? Ki the axis here is, this is the disk. If this is the disk, axis is perpendicular to its plane. If you could all logically register it in your mind, can I have a raise of hands, dear learners? कितने लोग ये बात समझ पा रहे हैं कि axis is passing through the center of mass and perpendicular to the plane of the disk? Can I have a raise of hands, everybody? Plane of the disk. Yes, take a quick raise of hand. Okay, everybody. Right. Take a screenshot then. We'll go to the next part. 5, 4, 3, 2, 1. Remember, for all cases you won't write half mr square. For different axes it will be different. This is only for the axis that is passing through the center. Chalo. Suppose we'll take a question from the previous year's JEE, right? Let's take a question from JEE 2019, okay? JEE 2019 से we are taking a question. JEE 2019. Okay? This question says that there is a disk, okay? There is a disk like this. I will make the disk. There is a disk ऐसा, which इसका mass is given to you. There is a disk. इसका mass is given to you as m, radius is given to you as r. They ask you, right, calculate its moment of inertia about the axis passing through the center and perpendicular to the plane of the disk. Like this, the axis is passing through the center and perpendicular to the plane of the disk. यहाँ से. But they say that the mass distribution is like this. The mass distribution is given to you. Mass distribution is given to you in this question as sigma is equal to, sigma means mass per unit area. They won't specifically say, but कई बार बोल भी देते हैं. They will say that mass per unit area. In 2019 they have given mass per unit area, or sigma is given as k into r square. Sigma is given as k into r square. Please remember, sometimes they'll also write this as sigma as a function of r. Sigma r is kr square. These both mean the same. Okay? They have same meaning. They have same. Sometimes they'll write sigma then bracket mein r. It means that sigma depends on r. I repeat, if they will write a sigma and then an r after it, it means that sigma depends on r. Okay? Right, everybody. So same r, same meaning. Okay? We'll take 4 more minutes before we end the class, dear learners. Yes. So take a screenshot, everybody. Anybody is remaining? Chalo. I think Makesh is left. We'll take this with Aanchal. Aanchal, ready? कर सकते हो? Ready?
Yes,
Yes.
sir.
है ना? आपको क्या निकालना है? Moment of inertia. ठीक है? Moment of inertia for the disk. खुद से करोगे या मैं आंसर बता दूं? आंचल
खुद से कर लेते हैं.
खुद से करना है. चलो ट्राई करो everybody. Yes, then we'll take not more than 1 to 2 minutes. ठीक है? I think that is not possible. So if you all want, I'll discuss this with you all. So yeah, you all want it as a homework. क्या करना है आंचल? बोलो. You want it
जैसा
as a
आप करो.
जैसा आप बोलो. देखो आया
अभी
मैं
करवा दो, घर पे तो नहीं करेंगे फिर से.
तो घर पे नहीं करेंगे तो नैया आगे कैसे बढ़ेगी आंचल जी? घर पे तो करना पड़ेगा. चलो टेक अ स्क्रीनशॉट एवरीवन. 5, 4, 3, 2, 1. ठीक है, चलो लेट्स डू इट. आई होप यू ऑल हैव टेकन द स्क्रीनशॉट, है ना? आफ्टर दिस लेट्स कंप्लीट द सेशन. सो वी हैव हियर sigma का value. What was it given as, Aanchal? Sigma
KR
was
square.
kr square. Let's write it. Sigma is given as kr square. We know this is equal to mass per unit area, right? So dm by dA is equal to kr square. What was this dA equal to? Suppose in exam, I'll give you all a trick also. Suppose you forget how to calculate dA. Although I just explained you all. Suppose you all forget. एक disk के लिए area क्या होता है, Aanchal? Pi r square.
Pi r square.
So what is dA by dr in this case? Tell me. 2 pi r. Differentiate करो. Yes, you get 2 pi r when you differentiate area with respect to radius.
Yes, sir.
अभी therefore dA कितना हो जाएगा देखो. 2 pi r dr. Same logic, same answer, but with a different logic. Clear, Aanchal?
Yes, sir.
वही आंसर आया but with a different logic. In last case what did we do? We had taken a ring, है ना? उसका thickness we had taken, उसका length we had taken, multiplied the two, and in order to get that we had calculated all of that visualization. Need not do any visualization. Very simple. Area is pi r square. Differentiate area with respect to radius. You get 2 pi r. Therefore, area for the ring is equal to that one elemental ring that you are taking. That is given by dA. Clear, Aanchal? Yes, Praveen.
Yes.
Praveen, are you clear with this aspect, Praveen?
Yes, sir.
Okay. All right. Vasu, clear with this?
Yes, sir.
He's far away somewhere. Huh? He's far away somewhere saying, yes, sir.
Yes, sir. Sir, I had gone to pee, so then I had to run and
Okay. Cool. See, I actually understand that you all are also as normal human beings as you, as I don't treat you all to. Sometimes I treat you as superhumans who will be seated in the class for long durations of 1.5 hours. But then again, it is just idealization, right? So I really understand that if you all are having food sometime, you're relaxed, kar rahe ho, coming late to the class or leaving early from the class is very okay, very understandable. If I'm strict anytime, it is just to make sure that you all are doing things पर्टिकुलरली परफेक्टली इन योर पॉसिबल मेजर. ठीक है, जितना अच्छे से हो सकता है उतना करो, इसीलिए आई एम ट्राइंग टू गिव दैट मोटिवेशन और कीपिंग दैट चेक ऑन यू. ठीक है, सो अभी आंचल दिस डीएम का डीएम बाय डीए का वैल्यू कितना है आंचल? 2πr इंटू डी आर. यस, दिस इज इक्वल टू के आर स्क्वायर. करेक्ट. यहाँ से कैन यू कैलकुलेट डीएम? व्हाट विल इट बी इक्वल टू? KR square into
2πr dr.
2πr dr. Praveen, from here let's take this with you. I want to calculate the total mass m. What will it be equal to for the disk? For the disk, what will be the total mass, Praveen?
K r power 3 by 3.
No. Tell me in terms of dm. Integration of dm.
Integration of
Summing up the masses of all the rings, we will get the mass of the disk. Correct, Praveen? So we
Yes, sir.
integration of k into 2 pi into r cube. Correct? dr.
R
Right?
Yes,
So we'll have
to dr.
pi into k r power 4 by 4, and the what will be the range for
zero
the range for
0 to capital R, sir.
so at the center it r will be equal to 0 and here r will be equal to capital.
Capital.
Okay, and when I say r, we are actually taking the radius of that disk or radius of that small ring. Small r is the radius of the small ring and capital R is the radius of the total disk that we are taking. And this is the case of non-uniform. ये कैसा case है? What kind of case is this, Praveen?
Non-uniform.
This is non-uniform or variable distribution of mass. What kind of case is this, Praveen? Non-uniform or variable distribution of mass. Repeat, Praveen. Variable distribution of mass.
Variable distribution of mass.
Write this, everybody. Variable distribution. You all should be good with the vocabulary also of this entire concept. है ना? Everybody will write this. This is. Otherwise, how will you all interpret when it comes in the exam? कैसे interpret करोगे if you don't know what you're doing, right? So, distribution of mass. Distribution of mass. Distribution of mass. Take a screenshot, anybody, if you would like to. 5, 4, 3, 2, 1. I hope you all are done. Okay, chalo. Okay, dear learners. Praveen, ready for the next part? Yes, Abhi. Abhi,
Yes,
let's
sir.
substitute the limits as you just told, Praveen. You all need not write, okay? Now I know you all are tired. Need not write. Write it tomorrow or day after, whenever you all are free. So, what will we write here, Praveen? Therefore, pi
2 pi k by 4.
Good. So pi by 2
Pi
into
by 2
k
k
times of r power 4 by
minus 0.
minus 0.
Yes, sir.
Okay. That will therefore be equal to pi k r power 4 by 2. What is this? Moment of inertia or total mass?
Total mass, sir.
Total mass. So right now we all, please remember everybody, we have not calculated moment of inertia, we have calculated total mass. Why have we calculated it? You will understand very shortly. They are asking you in the question, they are asking you the value for the moment of inertia for the ring. In this question of 2019, they are asking you the value for moment of inertia for the disk, not the mass. But still, I have calculated the mass also. Why? I'll tell you all. They are asking you moment of inertia. Okay? So let's continue. Mass ka values we have obtained. Now next part I'll write in a different color, say green. So what is the formula for moment of inertia? Once again, Praveen. Moment of inertia for a continuous body. For a continuous distribution. General
Integration of dm, sir.
x square dm. What is it?
Integration of x square dm.
So for a continuous distribution, we know moment of inertia is equal to what is it? Once again,
X square, integration of x square.
integration of x square dm. What is it? Integration of x square dm. है ना? Okay. Abhi we know in this case dm by da is called as sigma, and so we can write here. We can write here
dm
instead
equal
of
to
sigma into da, right? And what was da equal to? What was da? If a is equal to pi x square, then da will be equal to 2 pi x dx.
2 pi x. Yes, sir.
You will differentiate this dA by dx, and you will get as 2 pi x, and then you can get dA is equal to 2 pi x dx. Correct, Praveen?
Yes, sir.
Okay, let's write it here. So I hope you all are doing it well. Take a screenshot if you all like to. If you all would like to. So yeah, so we'll have Praveen this as x square into what? Acha, here you can take it as x square or r square, jaisa we all want. Okay, you all can also write it in terms of r or x. I am sometimes interchanging the two, but I really expect that you all are getting the idea, getting the notion. Correct, Praveen? Here I'm right. Sometimes I'm writing r, sometimes I'm writing x, but you all are clear, right? What you need to take, you can take x or r, whatever you all would like to. Correct, Praveen?
Yes, sir.
Okay. Okay, so so let's write it in terms of r only because we have followed r ka notion. So here is r. What was sigma given in the question, Praveen? Sigma was given as kr square, hai na? So sigma is kr square. Let's substitute. What is sigma, Praveen, in the question?
Okay, R square, sir.
Sigma is kr square. Let's put it here. Kr square. And what is dA here? Praveen?
2 pi r dr, sir.
2 pi r dr. Okay. Now, what will be coming outside? 2 pi into k. And what will remain inside?
R power
5. Dekho. R square, and r. It becomes r power 5. Am I correct, Praveen?
Yes, sir.
When you will integrate it, what will you get?
2 pi k into r power 6 by 6, sir.
R power 6 by 6. This is moment of inertia, hai na? Okay, but it is coming in terms of k, whereas we want it in terms of m. Hai na? We want it in terms of m. See here, Abhi, why did you all calculate the mass? You all will get the idea very shortly. So I can write this as Praveen pi by 3 into k and take the limits from 0 to capital R. Correct, Praveen? 0 to?
Yes, sir.
And this will come as 2 pi by 6 into k times of r power 6 minus 0 power 6, hai na? And the final value will land on the final value like this, pi into k by 3 times of r power 6. See here, Praveen, am I correct in saying this?
Yes, sir.
Okay, now Praveen, what was the mass value that we had just calculated? Mass was pi k r power
into k
4
r
by...
power 4 by 2.
Okay, let's remember it. Okay, can you remember it in your mind? Remind me when we go to the next
Yes,
step.
sir.
Pi k r power 4 by 2. What was the mass, Praveen?
Pi k r power 4 by 2, sir.
Pi k r power 4 by 2. Now everybody will see this step very very properly. ठीक है, ध्यान से देखना है everybody. So we are getting moment of inertia in terms of k, but when you are going to see here, यहाँ पे moment of inertia is given in terms of mass. How can you get the moment of inertia in terms of mass if you are calculating in terms of k? That is where we use this funda and calculate the mass also in terms of k. So I is related to k and m is also related to k. This logic we all will use in order to calculate a relationship between I and mass. Ye two relations we are going to use to calculate the moment of inertia in terms of mass. Yo, please all of you make sure that you all are practicing this question once again at least before coming to the next class. So I will be Abhi, let's divide the two. Can we divide the two, Aryan? So we'll have I by m. Praveen, I by m is equal to pi by 3 k into r power 6 whole divided by. Yes, Praveen. What can we write? Pi by 2 k times of r power 4. Correct, Praveen?
Yes, sir.
So pi and pi will be cancelled. 2 will go in the numerator, and k will also be cancelled. R power 4, and we'll be left with here r power 2. This is the ratio of I, or the value for I by m. Am I correct, Praveen?
Yes, sir.
So from this equation, we all can clearly see that I by m is coming as equal to 2 by 3 r power 2. Therefore, I is equal to 2 by 3 m into r square. Right? But this is no formula. This is just for this case. This is just for the given question. Do not memorize it. I will just 1 minute. My screen is stuck. Just for given question. Do not memorize it. Okay? Do not memorize it. Just learn the technique. What did we do? I will once again start from the front point. We'll close the class after, or we'll end the session for the day after this one. Praveen, which answer is matching with the answer that we're getting? 2 by 3 mr square is option number?
Option number D, sir.
Option number D. Okay, everybody have a look. हमने क्या किया, right? So case before this was easy, where we had to calculate the moment of inertia for the disk, and where we had to calculate the moment of inertia for the disk by just going ahead on and on, and we got the answer. Only one point of difference was ये sigma का value, ठीक है? This sigma का value comes outside because it is a constant. Case number 1, uniform distribution of mass. लेकिन if mass is not uniformly distributed and sigma is depending upon r, ये जो sigma है, this is depending upon r, in that case what do we do? ऐसे केस में हम क्या करें? In that case same logic will hold. You all can, अच्छा, ये need not do so much drama, right? You all can continue from that point also, what we derived in last question. But then just to make things clearer, first thing that इसमें we solve this question in 2 steps. In step number 1, we calculated mass. In step number 1, we calculated mass. Whatever funda was given, sigma is equal to kr square. This was given in the question, which is equal to dm by dA. From here, we integrated and calculated the value for mass. Ye step number 1 tha, okay? Then step number 2, we calculated the moment of inertia. Step number 2, we calculated moment of inertia. Yaad rakhna, the steps might seem large क्योंकि you are doing it for the first time. It is a very easy concept. Once you do it twice or thrice, ये मक्खन बन जाएगा. This will be as easy as butter, as easy as ABC for all of you. The way butter slips on a steel plate, similarly this is going to slip in your mind from here and there. Very simple. बहुत ज़्यादा don't complicate it by saying negative things about physics. Also, if you have friends around you who keep on criticizing physics, उनके साथ बार-बार physics को criticize मत करो. Please do not criticize physics or your skills, or don't doubt them when you are along with your friends. Sometimes your friends might not be working as hard as you are doing. So whenever you are with them, you know, in general friend circles, we say, अरे यार ये बहुत hard है, हाँ यार सच में बहुत हार्ड है, and we together start complaining and make that a big fuss about it. ऐसा मत करो, right? Be simple, be normal, it's okay. You feel harder, no worries. If you'll practice, you'll become better at it. Khatam. Need not cry about physics in life because that has an impact when you're doing it. If you keep saying physics is hard, it will start becoming hard. It's very easy, ठीक है? You all just saw कि कैसे easy था. So, moment of inertia for a continuous distribution, we went ahead, calculated the value for I and the mass, and then divided the two to get the final answer. Just for this given question, this is how we did. First case, calculated mass. Second case, calculated inertia. Then in order to calculate the relationship between the two, we divided the mass by area. Take a screenshot if you all would like to. 5, 4, 3, 2, 1. Alright, once again, if you all would like to, go ahead for a screenshot. 5, 4, 3, 2, 1. Thank you, Anchal. Thank you, Vasu. Thank you, everybody. We all will catch up in the next class. Until then, goodbye. आंचल आज आप आए नहीं थे, मैंने आप लोगों के लिए वजह से ही तो क्लास रखा था दोपहर का और आप लोग ही गायब हो गए.
मैंने आपको मैसेज ड्रॉप किया था ना, मेरी मैथ्स की टेस्ट शेड्यूल हो गई थी. हाँ, तो मैं उसका प्रिपरेशन के चक्कर में अटेंड नहीं कर पाई थी. मैंने आपको मैसेज ड्रॉप कर दिया था 12 o'clock अराउंड.
चलो ठीक है, तुम थोड़ा जल्दी आ सकती थी. जैसे कभी ऐसा होता है आप 2 बजे से आ जाओ, 2 से पौने 3 और फिर क्लास चले जाओ, ऐसा भी कर सकते हो.
नहीं, मैं एक्चुअली 12 बजे स्कूल खत्म हुआ और 3 बजे वहाँ टेस्ट का टाइम था, तो मैं वो टाइम पे पढ़ना स्टार्ट कर दी थी क्योंकि मैंने पढ़ा भी नहीं था मैथ्स के टेस्ट का और ऑफलाइन देना था. मेन प्रॉब्लम थी
उसका लाइक उन्होंने कल ही आज ही अनाउंस किया था क्या टेस्ट के बारे में?
हाँ, मुझे सुबह मॉर्निंग में पता चला कि मतलब टाइम चेंज कर दिया था उन्होंने. पहले लेट था, फिर टाइम चेंज हुआ.
चलो ठीक है.
थैंक यू सर.
ओके, चलो पूछ लेना, लेकिन आज चल अपने क्वेरीज अगर ऐसा नहीं कि रह जाएं. ठीक है,
हाँ मैं पूछ लूंगी. अभी तो बहुत लेट हो गई है.
नहीं अभी नहीं, अभी तो आई एम आल्सो पुटिंग द क्लास टू एन एंड. बाद में कभी व्हेनेवर यू वुड लाइक टू फील फ्री टू आस्क.
श्योर सर, विल डू. सर कल क्लास होगी क्या आपकी संडे?
कल मैंने तो अभी तक प्लान नहीं किया. कल तुम लोग छुट्टी बनाओ. अपन ट्यूसडे विल बी टू लेट. कल रख सकते हैं. तुम लोग फ्री हो दोपहर को? जनरली तुम लोग बहुत सारे इतने क्लासेस लेकर आते हो कि मैं पूछता ही नहीं हूँ तुम लोगों से.
कल 11 to 1 तो कल मैथ्स है. फिर अगर अभी तक तो धीरेन्द्र सर का मैसेज नहीं आया है, बट अगर हुआ तो फिर उन्हीं की क्लास होगी.
ठीक है, तो अगर ऐसा रहेगा तो कोई बात नहीं. मैंने तुम लोग को असाइनमेंट्स दिए ना, उसको फिनिश करके सबमिट करो. अच्छा
सर, ठीक है.
चलो, आई वांट ऑल असाइनमेंट्स. जो वो 5 क्वेश्चन वाले असाइनमेंट, उसमें से एरर एनालिसिस का आप लोग अभी बना सकते हो. रोटेशन और फ्लूइड्स वाला जो है, अगर स्कूल में पढ़ा हुआ है और उससे ट्राई करके बनाना चाहती हो तो मोर देन वेलकम. या फिर तुम HC वर्मा से रोटेशन पढ़ना शुरू कर दो? आंचल, एनीथिंग?
मैं HC वर्मा से रोटेशन कर लेती हूँ, बस वर्क एनर्जी पावर का भी बचा है तो मैं वो
और
कंप्लीट
तुमने
कर लेती हूँ।
फ्रिक्शन के असाइनमेंट बना लिया? फ्रिक्शन का
हाँ,
असाइनमेंट
फ्रिक्शन उसमें ही एक मेजर डाउट है, वो
उसका जो
बाउल वाला।
क्वेश्चन पूछा था ना बाउल वाला, वो आज तनीषा ने पूछा था दोपहर की क्लास में, तो वो आपको डिस्क्रिप्शन बॉक्स मतलब मेरे
ओके, मैं
प्लेलिस्ट
देख लूंगी लिंक
आप
में।
देख लेना आज, ठीक है?
ओके,
तनीषा
श्योर।
ने वही पूछा था, इंसेक्ट कर्लिंग ऑन अ बाउल, है ना?
हाँ सर, वही वाला।
वो आज मैंने डिस्कशन किया और भी उसने काफी सारे क्वेश्चंस डिस्कस किए थे, एक बार वन बाय वन आप
मैं
देख
चेक
लेना,
कर लूंगी उससे एक बार।
ठीक है?
यस सर, थैंक यू सो मच सर।
ओके, चलो ठीक है। ऑलराइट वासु, एनी क्वेरीज दैट यू वुड लाइक टू आस्क वासु?
No, sir.
Okay, so done. You're very clear with
Yes,
everything until now, huh? I'll take a test and you will go for 100 on 100, right? You're clear with everything. Hmm.
yes,
Vasu?
sir. Clear. Like as of now, when I
100.
start practicing, I'll realize.
And when are you planning to do that good job of life? Huh? Vasu, when are you planning up? Start, okay, Vasu?
Start. Yes, sir.
Send me the assignments by day after tomorrow as you have promised.
Yes, sir.
See, I am very, you know my nature, right? I won't be behind your back. I would keep
Yes,
reminding
sir.
you, but I cannot force you, and nobody can. Only a student by his own wish and will can move himself ahead. Nobody else can, right? I'll keep motivating you. Bye bye, Vasu. Good night.
Yes, sir.
All right.
So,
Chalo.
anything like I use the washroom.
Go. Please don't worry. Please don't worry about all of this. Yes, don't worry. Yeah. Good night. So, everybody who is listening to me right now, I hope you all had a good time understanding the concepts. काफ़ी सारी चीज़ें आज हम लोगों ने समझी जानी है ना. अगर आप भी इन्हीं क्लासेस को इन्हीं बच्चों की तरह मेरे साथ ज्वाइन करना चाहते हैं, फील फ्री टू कॉन्टैक्ट मी ऑन माई नंबर विच इज़ 7974 355 374. इसी तरह से हम लोग सीखते रहेंगे, समझते रहेंगे, अपने आप को हर दिन बेहतर बनाते जाएंगे और आने वाले वीकेंड पे और आने वाले वीक्स में फिर से मिलते हैं, इसी पूरी क्रिया को, इसी पूरे टेक्निक्स को आगे बढ़ाते हैं। आप लोगों को खुशवंत फतनानी फाइनली एंड तक लिया है आज के सेशन पे। अगर आप लोग इन्हीं क्लास पे पढ़ना चाहते हैं, मैंने आपको नंबर दिया हुआ है डिस्क्रिप्शन बॉक्स में। मेरा जो मंथली फीस है ना, दैट इज 3000 रुपीज़ पर स्टूडेंट, और इंटू 12 अगर आप करते हैं तो 12 मंथ्स का इट अमाउंट्स टू अराउंड से 36,000, लेकिन अभी उसको वी आर रनिंग ऑन अ डिस्काउंट, सो इसीलिए इफ़ यू आर गोइंग फॉर अ full 1 year installment for the fees, you can go for 27,000. That is 25% ka discount we have offered for everybody who is joining along with us. What do you get when you join the classes? You get the guidance along with the one-on-one discussion on the questions. आप देख रहे हो कैसे बच्चे ही खुद ही participate कर रहे हैं. The students are participating, the learners are participating, right, along with me as we go with the class ahead. और इस समय we are going for the chapter rotation. इसके बाद we are planning on to move to the other chapters. So अपना ख्याल रखिए, है ना. So अनुराग is saying, sir, I want to study from you. Sure अनुराग, अगर आप मुझसे पढ़ना चाहते हैं तो you can call or your parents can call and talk about your admission, and we can accordingly you can accordingly come and join these sessions. ठीक है. तो आपको मेरा अगर नंबर चाहिए, वो आपको मेरे चैनल के प्लेलिस्ट में सारे के सारे वीडियोस में ऑन द टॉप मिल जाएगा, प्लस डिस्क्रिप्शन बॉक्स में भी नंबर लिखा हुआ है. यू कैन पुट मी अ मैसेज ऑन व्हाट्सएप एंड देन कॉल एंड टॉक इफ यू वुड लाइक टू एनरोल फॉर दीज क्लासेस और द जूम सब्सक्रिप्शन. राइट अनुराग, आई होप आई एम क्लियर. हर क्लास को डियर लर्नर्स, डियर व्यूअर्स, जब हम लोग एंड करें उसके पहले कुछ अच्छा डिस्कस करते हैं, कुछ अच्छा सोचते हैं, कुछ अच्छा सुनते हैं, है ना. आज का अच्छा विचार यही है आप लोगों के लिए कि कभी अगर आप लोगों ने कमल को कीचड़ में खेलते हुए देखा है, भले कीचड़ में कितनी गंदगी होती है, हर तरफ उसमें मैलापन होता है, मिट्टी होती है ना, पानी होता है, लेकिन अगर हम कमल की पत्तियों को देखते हैं तो इस कीचड़ के बीच में रहते हुए भी सुंदरता कैसे पनपती है, कैसे वो अपने आप को अपने ऊपर एक हाइड्रोफोबिक कवरिंग लगाकर पानी की एक बूंद भी अगर डालो तो कमल की पत्ती से फिसल जाती है. आप देखोगे, जैसा मैं भी बच्चों के साथ डिस्कस कर रहा था, ऐसा बहुत बार होगा जब आप अपने लक्ष्य को चुन के उसकी ओर आगे बढ़ रहे होगे. ऐसे बहुत सारे लोग, कई बार दोस्त, कई बार ऐसी अक्वेंटेंसेस, कई बार रिश्तेदार, बहुत सारे लोग हो सकते हैं जो आपसे कहें यार तू नहीं कर पाएगा, यार मुझसे भी नहीं हो रहा, यार लाइफ ऐसी है, यार ये बोरिंग है, यार वो बोरिंग है, जीवन में ऐसा हो रहा है, वैसा हो रहा है. मतलब वो कंप्लेन से भरे हुए होंगे. ज़रूरी नहीं है कि हम उनकी भाषा शैली को अनजाने में अडॉप्ट करके वही राग अलापने लगे जो हमारे आसपास के लोग कह रहे हैं. कई बार हमें अपनी बुद्धि से काम लेना होता है. ऐसे लोगों के होने के बावजूद अपने आप को ऐसे ही खिलने देना होता है. We have to allow ourselves to blossom in the atmosphere of people where they are criticizing a subject or study in particular. क्योंकि आप लोग यहाँ फिजिक्स पढ़ रहे हो, राइट? बहुत सारे लोग कहते हैं फिजिक्स हार्ड है, ऐसा वैसा. ये उनका पर्सपेक्टिव है, ये उनका नजरिया है जो उन्होंने अपने लाइफ के एक्सपीरियंसेस से डेवलप किया है. जरूरी नहीं है कि लोगों को सुनकर हम वही बोलने लग जाए तोते की तरह जो वो बोलते हैं. हमारे हाथ में है ये चॉइस, ये डिसीजन कि अपने शब्दों को हम चुने. हम क्या कहना चाहते हैं किसी सब्जेक्ट के बारे में, अपने आपके बारे में चार लोगों के सामने क्या बुराई करना चाहते हैं. मैं भी ऐसा, मेरा फिजिक्स भी ऐसा, मेरी पढ़ाई भी ऐसी, मेरी लाइफ भी ऐसी, या मैं अच्छा, मेरा फिजिक्स अच्छा, मेरी लाइफ अच्छी. दिस इज द डिसीजन दैट वी टेक व्हेन वी आर कम्युनिकेटिंग विद पीपल अराउंड अस, है ना. आई होप ये बात आप लोग समझ रहे हो. तो जीवन में जरूरी है कमल की तरह खिलना. आसपास लोग कैसे भी हों, परिस्थितियां कैसी भी हो, अपने काम को करते चले जाना, आगे बढ़ते चले जाना. क्योंकि अगर आपने कोई लक्ष्य चुना है ना, तो आप जानते हो आपकी फैमिली की इकोनॉमिक कंडीशंस क्या है, आप जानते हो कि आपके जीवन का लक्ष्य क्या है, आपको क्या करना अच्छा लगता है. इट नीड नॉट बी द सेम विथ 100 पीपल अराउंड यू. तो हमें अपने अंदर की यूनिकनेस को बरकरार रखना है, even if we are surrounded with people who have opposing or very different mindsets from the ones which we bear or we would like to bear. I hope ये सारी चीज़ें आप लोगों को अच्छी तरह से समझ में आ रही हैं, आप लोग सीख पा रहे हो, सुन पा रहे हो, समझ पा रहे हो. Anurag is saying, sir, have you recognized me? Not yet, Anurag. Feel free to talk about your recognition, maybe over a call when you put a call to me. Right? I hope ये सभी लोगों को क्लियर है. आप लोगों से विदाई लेते हैं. Thank you everyone. अपना ख्याल रखिए, अपनों का ख्याल रखिए. This is your educator Khushwant Fatnani signing off for the session for the day. कमल की तरह खिलना है, अपने आप को बेहतर बनाना है. Until then, good night.